I think the last class lecture, I was not really active, and I tried to see how much I can go through the last session's video to get one or two things. So I can't really say something about the last class because I was not really active.
Okay, so we'll move to Madam Theodora. Please, let's have your take home from the last class. I don't know if Madam Theodora is on.
Oh, sorry, I forgot that I was on mute.
Class.
Yeah, I am.
Muted.
Yes,
okay.
I'm unmuted now. I said, sorry, I wasn't in the last class. I'm just beginning the class today.
Okay, you are welcome, please.
Thank you.
All right, so please, could you just introduce yourself to the class, what you do?
Okay, my name is Theodora Okafor. I work with the Standards Organization of Nigeria. I'm in this class to get as much as I can get because I handle the Nigerian Industrial Standards for Facility Management. So that's why I'm in this class. I want to take home as much as I can to make.
You're welcome.
Okay, thank you.
You're welcome. We're happy to have you as part of our class, and we believe we can learn from you as well. So
thank you, sir.
All right, so we'll move to Awi Tafik. Please, probably as we are going ahead with our take home, let's do a brief introduction for the benefit of our facilitator today. So Awi, you have the floor.
Good afternoon, sir.
Afternoon.
My name is Awi Tafik. I work with every contractors in Lagos. So my take home from last class was about
Please, you are muted. You can unmute and let's hear you.
Yes, sir. My take home from last class, I forgotten. I'm just rushing down here now. So I'll update you very soon, sir.
Okay. Moses Obotu.
All right. Good afternoon, everyone. My name is Moses Obotu. I'm a facility manager with Cosgrove Investment Limited in Abuja here. So my take home from the last class about FM organization levels, it's about there's a double inverted cones from the introductory part of our course material there. And there it shows the different levels where FM operations happens. There's the strategic level, the tactical level, the operational level. Now, what I got to learn from that illustration is that we should always have this ambition to get to the strategic level. We see the strategic level there. There are very few number of individuals that attain up to that height. But if you look at the performance, the cost of their efficiencies, and if they make any mistakes at that strategic level, it has if you look at the corresponding inverted cone, it has a very, very wide impact on the operations of any facility management company. So, but you see the operational level, yes, it can make errors, but it doesn't has a wide area of span of coverage like that. So it is one of the things I learned from also. Furthermore, I also got to know that for the FM organization models, there are some basics we need to know. We need to know about our customers. We need to know about our functions in the particular organization, about our site, to know about the space we manage, to know about the organization we manage, and how important or crucial the functions that we render in that organization goes to aid the client meet his goals for that organization. So that was some of the few things I learned from the previous class. Thank you.
All right, thank you. So I think we'll take finally from Toby Loba, then we'll have the facilitator continue with the session for today. So Toby Loba, please ride on.
Good evening, class. Good evening, everyone. Happy weekend too. My take home from the last class was from the agreement, if or whenever we find ourselves on the consulting end of the industry. Whenever we are having our contractual agreements with the client, we should never forget the non-poaching agreement with the client, so that we are not left in the cold at the end of the day when the client decides to disengage on the contract with our firm or the company and then poach our hands. That's the hands of our staff. That's very important. And finally, the basics. Knowing our basics, knowing what the client's company and their business is all about, in order to have a robust contract agreement that does not leave any thing to chance in the contractual agreement. So those are my two takeaways from the last class. God bless you.
Right, thank you. I think we have substantial members on connected now. So please, sir, we ask you to please continue with the session.
Okay. Yes. Good evening, all. Yes, I'm engineer Odibo Edesiri Ejurogene. Worked in the HVAC industry for over 10 to 15 years. Then before I move into facility management. So like you have rightly said from your take home from last class, there are things that is required as a facility manager to ensure. If you see the failure in our society today is because of lack of maintenance. So managers or facility management company to take care of their facility to ensure their building is safe at all times. When we watch football, you see the standard of the TV screen. You see that their facilities are in place. But if you go around Nigeria and see some of our facilities are stadiums, government parastatals, building, and the rest, you see the state of decay that the building is. So your duty as facility manager is to change that narrative, change that orientation, and make your facility one of the best place customer would want to come. So on that note, I would like to talk more on HVAC maintenance, because this is one of the components that you must manage every facility. So before I start, I give a brief history of air conditioning system. There was nothing called air conditioning system in the past. People of old look for how to cool themselves, but there was no way. But if you check our globe, divided into areas that have cold region and areas that have more hot regions. You have the desert, then you have the areas, the Antarcticas, the Iceland, the Russians, and the rest. So people discover some part of the continent have ice and the other part has heat. So what they do those days is to cut part of those ice and bring it to areas where they are needed. But it's an Herculean tax, traveling all the way to the Atlantic, go and bring the ice, bringing it to the wetland. You need to preserve those ice. Probably it is during those periods they were able to design what they call coolers, something that can retain the temperature of a particular product or item when it gets to its destination. So along the way, development led to a lot of things, and people started looking for how to produce cooling, irrespective of location and the rest. That is how the mechanical engineers, the electrical engineers all came together and were able to produce what we now call the air conditioning system. And the air conditioning system is something that's revolutionized building. when we still have the early man. You know, the early man stays in caves. You know, when the caves only have one entrance, when he saw that he's exposed to different kinds of animals in the bush, what does he do? He has to create a barricade, block the way in. And in blocking this, he discovered he generates heat. There's no form of ventilation. So he looked for ways, how can I access outside and still remain indoors? They created a window. So most building today has what we call window. So some windows, some of the buildings have their window open, some have it closed. Then how do I go out and how do I come in? That is how we come about having doors in our place. Then how can I get the inside cool without affecting the doors and affecting the windows? So they brought about the air conditioning system. Not just the air conditioning system you think about ventilation too. If you remember, some of our brothers that do traveled to Europe via containers, they will lock themselves in the containers and travel straight 2 days, 3 days on the road before they get there. When they get to their destination, what happens? Most of them die of what? Suffocation. It's possible you have air conditioning in a building and still you do not have ventilation. And why do you need to be ventilated? Because you need oxygen to survive. If there's no oxygen within your space, it affects your productivity. It affects how you do things. So what you need to look out as facility manager to see whether the air conditioning system within your building is sufficient for you. Then two, you need to carry out air quality of your environment to see whether the oxygen coming into the building is sufficient for your workers. Because if your workers are not turning their best, probably they are lacking in oxygen. Because once you lack oxygen, you are going to struggle trying to fulfill. I would advise us to be on mute. Can we be on mute? Can we all be on mute? The governor, can we put everybody on mute? Please, once you have done that, let me know so that I can proceed.
Okay, Baraka, please kindly put all the participants on mute.
Okay, sir.
Okay, is that done?
Yes, sir.
Okay, please. The essence of this training, in my class, I do tell people that you don't need to carry book to teach people about air conditioning system. You need to create the interest in you. Once the interest is created, every other thing will put itself in place. You understand? So you must listen attentively to the lectures. It is what you have paid for, and you need to benefit from it. So, like I said, oxygen is required within the facility. So different means was brought together to ensure that the air conditioning system is required in the building. Then I also ask a question, why do we have things in ShopRite and things in my 12th market? I will go local so that you understand clearly the point I'm trying to make. For a woman that just has some millions of naira, she wants to establish a shopping mall, maybe within the area. The first thing she thinks of is how to keep the customer coming in cool. And that comes about you bringing in air conditioning system. You having in a church, you have congregation close about 1,000 or more. You see them praying, singing, and they are sweating. In order to solve that, you bring air conditioning system. Even in our mosques on Friday, when we go in, a bigger mosque, you see them putting air conditioning system. What of large structures, skyscrapers that we have on the island, all those buildings where businesses are carried out. The essence of air conditioning is to create comfort for your occupant. In creating that comfort, a premium price is placed on it. If you want to go and rent a shop or a business center that you want to start your business, you'll be so if AC is not provided, definitely the value of that facility definitely go down. Because if you are providing air conditioning system, the value of that facility go up because it's part of the charges you are going to charge your customer. You understand? So air condition is a single component that ensure business remain indoors without you being outdoors. If you check most of the churches built in those days, you see that most of the churches are gigantic. If you check some Anglican church, the Catholic, Methodist, then I think the Winners Chapels, you see the way they are built. The essence of that size is to accommodate large volume of air that can actually cool the people without air conditioning system. But if you are now doing physical activities that make you generate more heat, then you need form of cooling within yourself. So air conditioning system is very, very important in every facility. Being in charge of maybe an oil facility, Chevron, being in charge of a bank, your data center also need air conditioning system to work fine. If your air conditioning system in your data center fail, that bank might be bankrupt in the next 1 to 3 months because your server actually depend on the cooling that you give them within that space. Because on weekends, when you go and withdraw, you notice that some certain banks, their servers are not working because probably the cooling is not working or the server system is not getting required cooling for them to function. So that single thing could actually affect customer coming into the bank. So facility managers, you have greater role to play in adding values to your customer because that value depends on your own performance. Because once you bring in value, your performance is definitely high. When you are not bringing value, your performance will go. If you enter a facility, your first duty is to check whether everything is in position. That's why you need to do audit or you do what they call conditional assessment. All those things matter. So your role will now be, this is the condition when I come in. This is the condition I want the building to be in the next 1 year. So you start making plans, trying to make some changes. And if money is not sufficient, you do what they call ROI, return on investment. You get budget for it. Then you start calculating how you do your ROI to get return on investment. So the air conditioning system is a symbol important. So we start with our maintenance plan. And don't forget the HVAC, the heat, the H there stands for heating. I believe you can see my screen. I believe all can see my screen.
Yes, I can.
Yes.
Okay.
Yes.
Okay. So let me go ahead. I want to be sure before we start.
Yes,
So
yes, yes.
yes. Okay.
Yes, I see your screen.
No problem. So first of all, you ask yourself, what is maintenance? Maintenance in general can be defined as an effort taken to keep the condition and performance of a machine always like the condition and performance of the machine when it is still new. So you see a vehicle, your air conditioning system, a vehicle, be it a machine and the rest. The essence of that maintenance is to ensure that the purpose of that machine is fulfilled at all times. If your equipment is not being maintained, your AC is not being maintained, there's every tendency that it will break down. And that breakdown can cause a lot of loss to the company, can cause of customers withdrawing from your building. Maybe a shopping mall where you have averagely of about 10,000 people visiting every day. And just within 1 to 2 hours, your AC failed. Definitely people will move out. And you have already given a bad impression to people that come to shop in that the shopping mall. They will be the one doing the marketing. Ah, man, if you go to that shopping mall, their AC is bad, their AC is terrible. And if by mistake they now know your name, you're already in a big soup. In case you are changing your job, you'll be in a big problem because your duty is to ensure before it breaks down, you ensure that the condition of those things are put in good use and are checked and are maintained periodically. So you get that. Then we have different kind of maintenance. One is peculiar to Nigerians, and the other is peculiar to those that are Nigerians that are advanced in nature. The reactive and unplanned one. This is our custom here, most especially with the black men. We don't maintain our equipment. We must tell ourselves the truth. If it does not get bad, we do not fix it. This should not be the tradition of facility managers because most of us are managing big facilities. You must at no time agree to reactive maintenance. Reactive maintenance leads to loss of man-hour, leads to time loss. It also leads to people pulling out from the facility. So we also have the other part, proactive and planned maintenance. Proactive or planned maintenance is before the equipment gets bad, you're already there, you already make a plan. Is it going to be a monthly maintenance? Is it going to be a weekly maintenance? Is it going to be quarterly? Is it going to be biannual, or is it going to be annual maintenance? So it depends on your facility. You can now work out a PPM that suits the need of your facility. It is very important. Don't say because the equipment is working, is still in use, why should I pay money for maintenance? The day the equipment will embarrass you, you will not believe it, because your top managers can be in a meeting and the ACs just went down. Then you know the question that will come out at the end of the day. Can you please call the facility manager? What happens to the AC? You now start giving an answer. We didn't know that the AC is going to, that is high level of irresponsibility for facility manager. Explaining when you know what to do. So you must be proactive at all times. Facility management is a serious business. You understand? Then under the reactive, what you can also get there is a corrective or emergencies. If you are the facility manager that loves emergencies, then the advice is don't plan. Just wait till when it breaks down before you fix it. Then corrective maintenance too, it is when it has fault or is giving sign and is showing sign of breakdown before you react or you do what you needed to do. That can lead to a lot of waste and man-hour. Like one of the estates I once managed, the condition for the building is that light must not go beyond 5 to 10 seconds in the facility. That's why you don't have light around the whole area. This particular place I'm telling you is in Lagos. And I know we have such places all around Nigeria. But they don't allow light to go beyond 5 to 10 seconds. Why 5 to 10 seconds is because the timing for the generator, once the generator senses there's no light, it switch automatically to generator. And once it discovered that we have PACN, it automatically switch back without any disruption to what they have in the building. That is what the client wants. That is what they plan. Then if your facility is the type that wants something done 12 hours, you work your plan in accordance to the scope of what is on ground. Please don't forget, under the proactive one, we have the preventive and the predictive. Then under the preventive, we have the constant interval, the age-based. Your generator is still working, but you saw that from the manual that the generator or the AC need to be changed every 5 or 10 years. You can make a plan to change it. Don't let it to break down before you change it. That's why they call it preventive maintenance. Then predictive. Predictive is associated you checking probably a graph. Some of your manual will follow a graph. When you see the signs on the graph that this thing yesterday is giving us about a 70% efficiency, even while we need it at 100%, the graph also show you that the efficiency of the machine is dropping. Because you understand the graph, you know when to overhaul, you know when to start your maintenance immediately, because you want your client to be happy. So you put all those things into condition while you are planning for your AC maintenance. Then major focus of your facility managers are for the people. You take care of your staff, your visitor or customer, even yourself that is coming into the building. These are people that are of top priority. You don't want to have a bank where you have people coming in every day. The first thing they complain about in your facility, this AC is bad. Oh, this place is too hot. I don't think I will come to this branch. Let me go to the other branch that they have AC. And if you're in charge of that facility, as a facility manager, you have failed in your responsibility. Nobody should complain about cooling coming into your environment. And don't forget, when you watch movies, you need to put your air conditioner to maximum use, because there are some movies that are scary. And once movie is scary, or there are those emotional type of movie, when you cry or you are feeling scared, you generate more energy. So your AC should be able to take care of those heat. Though coronavirus have caught us going to cinema, we have enough spacing now, but that, in a way, you can factor what works out for you. Then the process, it could be activities carried out within an organization. That should be an organization with the aim of fulfilling the business objective. Why do the company form their business? Is it to produce? Is it for people to store their money and do transaction of finance? Is it because of, is it a stadium? Is it a cinema? Is it a church? What are the activities that are being done within those places? Those activities also have direct impact on the kind of AC you use. You look at it before the outbreak of the COVID-19, you see that there was an increase in building of all these event centers in Nigeria. Those event centers actually gave birth to using air conditioning more, because most of the event centers were actually using walls, blocks, bricks to build them. But all of a sudden, they discover another cheaper means to build them by using those nylon materials, using canopy-like materials to build. And don't forget, when you use a canopy-like material to build, the temperature increases while the sun rises. So you need to ensure you design at maximum for such places, because it's possible you are within that event, the ACs are working and people are not feeling the impact of the ACs. So you need to consider the kind of activities being done there. Is it a club where people dance at night? Is it a club where people, is it a party hall? Is it an event, a marriage where people will dance? You don't need to dance for where a design for library is different from the design for a church. A design for library is different from a club or a party ground or an event center. So all those things a facility manager must take into consideration. Your most important thing is to ensure the activities and the objective of the company is met. You understand? Then places, you talk about location, site, home, and the rest. You understand? You need to consider the place your building is located, and the environment your building is also located. If you locate your business in a dusty environment, the cost of your maintenance definitely will go higher. If you are in a high-rise building, definitely your ACs are supposed to be on top of the building. And if you have places, you put them on the ground floor, then fine for you. But what matters a lot is the places your business are being carried out. Why do we need to maintain our HVAC system? To create comfort, improve indoor air quality. We ask ourselves, how can AC improve indoor air quality? You know, when I was doing my introductory talk, I said that some buildings, their windows are closed 24/7, they are not open. While some, their buildings are open. Each time, and if you are in a dusty environment, dust will definitely find their way into your space. Have you ever traveled for a long time, 2 weeks, 1 month, 3 months, and your doors are shut? You ask yourself a question: how do dust get into your apartment? When you check your table, you see some coated dust on top of your table, your television, your screen, and the rest. How did they get into that place? You ask your question, the dust are everywhere. So one importance of air conditioning system is that they have filters. The essence of the filter is to remove this dust from air. Because if the dust gets too high within your space, there's tendency your staff will be sick. There's tendency you will develop what they call the sick building syndrome. People will start sneezing coming into your building. Somebody that came normal has picked up a disease while they are going out from the building. So you need to ensure the indoor air quality of a facility is a top notch for your workers. Then it saves money. You know, when you save money for your company, it's always a plus to all facility managers. Every time your unit is being maintained, you have been in a building for 5 years, you've never had an emergency, because one, you ensure that your AC, your HVAC system are maintained periodically. And if you maintain periodically, you save yourself from emergency. When you call a facility, an HVAC company to come and maintain for you, when you have emergencies, they tell you, okay, I no go get time. Oh. See time when they call me, we don't close for today, or it will be tomorrow. And your client is on your head that this thing must be done today. Sometimes you have to stay late if they agree to come to site, the HVAC company agree to come to site to ensure they do the work before the next day. So this can lead to loss of man-hour, lot of time, the money will be wasted. Don't forget, the man that is coming to do the work late will definitely charge you premium price. So when you do your maintenance periodically, you reduce headache from yourself. To reduce total breakdown. So when you do your AC servicing every time, the number of breakdown will be 0 in your facility. And that is another point to which your company can commend and probably promote you. Then to prolong the system lifespan, each time you maintain the equipment, the efficiency of that equipment work paramount and work beyond the lifespan of the equipment because it's being maintained. I know of a man that used one 504, and that 504 lasted the man for about 5 years. He had 1 or 2 accidents on the road, not really serious one. When you see the vehicle, it looked brand new. It's because of what? The man ensure periodic maintenance of those equipment. So the equipment in your facility can also be a top notch. And don't forget, when you are disposing of your equipment, if the equipment are in good condition, you can still get good value for selling them after using them for a while. So if they are so old, the metals on their body are rusted, definitely you don't expect a premium price on such equipment. Then to reduce noise, once you don't maintain an equipment, some mechanical components start developing faults because vibration comes in and it distorts within the environment. So things are struggling to work. You start hearing noise from your AC anytime they put them on. To keep the humidity and temperature within regulated amount. Humidity, you might ask, what is humidity? Humidity is the amount of water in air. Amount of water in air is very important for every human being. Nigeria presently, we are in rainy season. Those of us in Lagos, we're experiencing rain. The essence of that rain is sometimes the air absorbs some of, and that water is required for us to breathe in freely without anything. The air within our nose are standing to prevent other diseases coming in. Then when you understand the humidity better, it is during the harmattan period. During the harmattan period, the quantity of water in air is very, very low. And at this time, the air within your nose are either through your gum, your nose mucus, they stick to the body and open wide. So most lung disease or infection actually increase during this period of the year. During the harmattan period, people begin to sneeze, people begin to cough, people, even coronavirus too, they've taken to this period. When there is cold, the coronavirus infection increases and the rest. So if you do your constant maintenance, the humidity of your equipment and the temperature of equipment remain within an amount. And if it is not well regulated, you have more than enough humidity in air, don't forget, microorganism also grows when they see water. Then you ask yourself, our scientists going to space, what are they going to look for in Mars? They said if they can see a drop of water, they will know that life exists in Mars. I don't think they've seen any water yet, but we have enough on Earth. So in your building, when you have more than enough water in air, definitely you are going to be having mold growing in your wall. You see some of the paintings of your wall getting damp because you have excess of water in air, and this can lead to disease. And don't forget some of those microorganisms, either bacteria, fungi, or viruses, they bring out some chemicals that when we inhale them, affect our health. So in order for you to ensure your equipment is at top notch, your equipment must be well maintained. And to improve the efficiency of electrical system, you might ask, how could this be? If your system is not well maintained, maybe your filters, if it is not well maintained, it can have a direct impact on your compressor, because when the return air is coming in from your system, your AC is supposed to detect the condition of air coming. But once you have filters, too much of dust on your filter, it doesn't allow those air to come in. So the system does not understand what is happening. So thereby seeing that the compressor is overworking, just like your car. A good example of your car. If your radiator is clogged and blocked, what happens to your engine? It begins to heat up. Just one action is leading to another thing within your vehicle. So until you clean that radiator before that engine's temperature drops, if you don't, that engine could actually develop problem. Some vehicle will just stop running until they cools down again. You start again. For how long will you do that? The same thing happens between the filters and the compressor. If your filters is not 100% clean, you see that your AC work optimally, and if it overwork, there's tendency your compressor can fail. To keep our data center running, each time you maintain your equipment, you ensure your data center is running. Then I will teach you something. There's what we call redundancy in air conditioning system. When you are designing for a data center, if you are to give the data center 20 kilowatts of cooling, please make your design to be 30 kilowatts. There should be an equipment on reserve in your facility, so that if one out of the 20 kilowatts has broken down, you can actually activate the other one while you are fixing this one problem. Your data center must continue running at the temperature they are set to. Then what is HVAC? HVAC stands for heating, ventilation, air conditioning system. The heating, you might ask, Africa is located most especially Lagos. Lagos is located along the equator. Why do we need heat? You will need heat when it comes to the wet season, where sometimes everywhere is cold. People cannot use cold water to bath and the rest. There are some air conditioning systems that can actually heat your apartment. They call them a heat pump. They are expensive. They call them the heat pump. Just by pressing your remote control, your AC can actually, your room can actually get hot, and it can also cool at the same time. I remember in one of the facilities we maintain, somebody started tampering with the remote control. So when you go into the facility, you experience part of the building is actually Europe. Then some other part of building is like Sudan and Libya, because somebody went to press the heating and put the temperature at 35. You see the manager in the office was sweating while wearing suit. So the man has no choice than to pull the suit, call the facility man, what is happening in my office? What is happening? Knowing somebody that worked previously in that place, press the heating element and started heating up only his own office. When he comes outside, I saw that every other place is cool, while his office is hot. And the simple solution was to revert what they've done within the remote control and reduce the temperature to cooling. So we have equipment that can do that. So, like I said, the H stands for heating. Then we have ventilation. Ventilation is a means of bringing oxygenated air into the place while they are on motion. Ventilation is when you cool your body and you are getting more oxygen. If you check our village, when you go to the village, you see that a building is not built without a tree. Most of our villages, and if some of us have visited, if we have not visited, this is an opportunity for us to get home and see the setting of home of our village. Most of them don't use AC, but they have their local way of cooling themselves. Once they see that the indoor is hot, they go and stay outdoor under the trees, and they get the maximum cooling that they want within that place. Then the air conditioning system is actually the mechanical component in which we use to do what? To create or change or influence temperature within a space, either to make it cold or hot, which is used to maintain or control an environment within the building of the occupant or for the process of being conducted. To maintain the environment, the HVAC system controls some factors. We've mentioned temperature. Once you use your air conditioning system, the temperature within your building definitely will be controlled. If it was an interactive class, I would have been asking questions, but I will go along. The average temperature of human being, if you mention, is 36. If your temperature is lower than that value, you are getting sick. And if your temperature is getting higher than that value, you are also getting sick. You need to see your doctor. Average normal temperature for person or people is 36 points. It should be between 36 and 37. It should not be beyond. If it is beyond, there's something wrong with that person. Then don't forget, most of our engines are also designed in that factor. Your laptop, sometimes when it gets overheated, you will see the sign on it. That's why in your system, you see that there's a fan created to remove heat from your laptop. What of our car? Our car engine is designed with a particular temperature. Once it exceeds that temperature, that is when it shows on your dashboard that it's overheating, overheating, overheating. So those things matters a lot. And don't forget, the coronavirus has taught most of us our body temperature. Before you enter any facility, there is this infrared thermometer that is pointed at your forehead or your hand to assess your temperature before you gain entrance into the facility. So if you understand that thing, you now need to know at what temperature will be comfortable for an indoors. Definitely, you will know if the temperature is, I don't know, if there's a blackboard here. That means I'll have to be coming back here. I want to draw something. Hello, Governor. Okay, I don't think it's possible here. Okay, let me just write on. I wanted to draw something for you, but nevertheless, I will explain. Please, I just want you to visualize something. If the body temperature of somebody is 36, in order to make the person body temperature cool, do we increase the temperature or we reduce the temperature? Hello, I need a response for that.
We reduce the temperature.
We reduce the temperature. Yes. Thank you very much. Let us not forget that music fella sang, water not get enemy. That if your pikin sick, what thing you go do? You go pour water for him. The essence is to do what? To reduce the temperature. Then the women among us, I don't know if the men actually take their children to the hospital, but I know the women does. Once you take your child that have high temperature to the hospital, the first thing the nurse asks you, have you bathed the child? The essence is to reduce the temperature of that child first before it is treated. So coming to our office, if your temperature is at 36, ASHRAE, there's a body called ASHRAE. ASHRAE is American Society for Heating, Refrigeration, and Air Conditioning Engineers. They are a global body that gives standard for different conditions relating to heating, ventilation, and air conditioning system. They set up standard. They've told us that a temperature of 20 to 25 is a temperature, no, 22 to 25 is a temperature we human beings work optimally. So if you must get to your office, you need to check your thermostat when the environment is getting hot or somebody is complaining. What is the temperature of the thermostat? And don't forget, you need to still put a thermostat somewhere different from that thermostat. Because when you increase the temperature on your remote control, the instructions you are passing to the AC. You are either telling the AC to get the room temperature to the temperature you are. If you put it in 18, the temperature of this the space might not necessarily be 18. Please don't mistake that, because that has caused trouble in some facility. I might set a temperature of AC to 18. Does not give you guarantee that the temperature of the space will be 18. You're only telling that AC to get the temperature of that space to 18. So if you now set up a different measuring device, temperature measuring device somewhere, if this one is giving you 18, there's tendency that this other one will be giving you 20. The AC is still doing its work until he finally gets it to 18. So don't mix that fact, because some of your clients might call you that, why is this thing showing 18 and the temperature in the place is so hot? So you now need to explain that to your client so that they will understand. They need to give the AC time for it to work efficiently and more. Then we go to humidity. Humidity, I've told you, is the amount of water in air. So if it is too much, you see mold growing within the air. If it is within moderate, your staff will work efficiently. Then if it is too low, it causes what they call static electricity in your electronic device because it is too dry. Then the air within the electronic device will start generating positive and negative. And when they clash, they can actually destroy equipment. Then air distribution, your AC, by virtue of movement of cool air and taking hot air, they create a form of movement that is required for us to cool. I've also asked and I've told my students severally that you wonder how the world look like, how beautiful it's created. There's no air conditioning as big station somewhere that is cooling the world. How do we get cool in the world? In physics, we were told we have what they call the land breeze and the sea breeze. There's a relationship between the sea, the land, the sun, and the moon. They control the movement of the air. When the sun heats up in the afternoon, the water is heated, the land is heated. Because the land is a good conductor of heat, it gets heated faster than the water. And before you know, the air at the surface of the land rises up, and nature does not allow vacuum. You can try that with a nylon, you can try that with a balloon, you can try that with your Regulus bottle water or any bottle water. Once you press it, just release it. Once you release it, you see that the air will rush back into it. So nature itself does not allow vacuum. So the hot air on the land, as it rises, the cooler air from the sea takes over. So because of that movement, we human beings are cool worldwide without any electrical equipment, without any mechanical equipment, but by the forces of the sun, the land, and the sea. Very, very important. Then air quality. I've also told you that every air conditioning system is fully equipped with a filter, either bigger system or smaller system. The essence of the filter is to ensure dust get treated, get removed before coming out. So in terms of filter, there are different type of filters. We have what they call HEPA filter, which is normally used in the hospitals. You ask, why do they need such a filter in the hospital? Don't forget, microorganisms also grow by virtue of this air movement and air velocity. These microorganisms can actually move to areas where people are not infected and begin to cause havoc. A good example is the COVID-19. When you see somebody sitting close to you in a bus and the man is sneezing continuously, you know, they don't tell you. You'll be looking at the man while you are wearing your nose mask to prevent yourself, or you tell conductor, I beg, I want to come down. Because we know the effect of what the COVID-19 is airborne, and people can take it from air. So some facility that knows high quality, they change their filters to ensure that a bit of that COVID-19 does not get into their facility because it can spread. Then air velocity is the speed to which the air moves from one point to the other. So you might ask, why do we need air velocity? Don't forget, when you store an AC in a very big hall, the AC actually has the distance it can travel. If you don't take that into consideration, people closer to the AC will get the cooling, and people further from the AC will get heat, because the air velocity determines the distance it will move. The more the velocity matter in office. When you have in your building, hello, can you hear me? When you have a central, can you hear me? Hello,
We can
hello,
hear you
Governor.
now. We lost you a while.
Okay, sorry. I believe if it's time for your break, you let me know so that you guys can have a break a little, then I continue. So to make sure that the lesson sink in very well. Then, like I said, you need to design, like if you check some offices that use a central system, you see that there are different diffusers at different points. The essence of that is to ensure that everybody within that space have enough cooling. You don't want to design and half of the building have cooling, then the other half is having heat. And I can tell you categorically the efficiency of those children of those staff will be affected. There was an experiment carried out in the US. They use an environment where ACs are installed, an environment where ACs are not installed. Even in workplace, that of workplace, they discovered that people that works within an air conditioning environment has greater productivity. The efficiency of discharging is affected and is running into 100, even beyond 100. Even equipment, once ACs are installed, they work optimally. In your cars, if you are the type that stays in a very dusty environment and your glasses are always down, you'll be surprised that the level of dust that goes into your vehicle. But with AC, the air within that place is clean. Your cars are clean at all times. So AC is a single factor in your building. Don't forget noise level. When you are installed, those days before AC came to play, we have what they call fan, and those are our fan. Those ones that we have used for over 20 years that we are not fully taking care of. They will just decide to embarrass us when visitors come to the house. That is when they will start shouting na 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 when they are walking. Your visitor will look at you, say, okay, why is this thing making noise? You're out of shame. You will put this up, oh boy, let me go sit down outside. You understand? But for air conditioning system, that is totally taken care of, because the fan used in air conditioning system are actually a butterfly type. They work and they produce little noise. And don't forget, some people don't like noisy environment. Once AC start making noise, it affects productivity. I've seen people move out of their office because the ACs are making noise. So you need to take control of all these things that I'm mentioning. Hello? So there are 4 basic things you need to consider in air conditioning system. The 4 basic things are what? The evaporator. Very, very important. After the evaporator, we have what they call okay, let me start from the condenser. We have the condenser first. From the condenser, we have what they call the evaporator. From the evaporator, we have what they call TSV, thermostatic expansion valve, somewhere around this place. Then somewhere along this place, then before you have your compressor. These 4 components work together to give you the required cooling. So I will explain how it works. First of all, when you switch on your AC, the AC begins to work. It takes some few time before your compressor starts. Why does it do that? In your compressor, there's a particular oil inside your compressor. Our madams in the house will understand what I'm saying. When you leave oil, groundnut oil or palm oil in a very cool environment, what happens? It cakes. So it takes time for you to fry or cook. You must put it in a heated environment for it to move. So the same thing also happens in your compressor. That oil is to aid easier movement of the refrigerant. So when you put it on, there's a heating element within your compressor that actually heat up that oil. So once the oil is ready to move within the copper pipe, what happens? Your compressor just pump on. It picks up. And when it picks up, what does it do? There are 2 major components you need to consider. Let me see if I can actually, I'm supposed to have a screen here. Okay, I think I've seen it. Okay, I can draw this white. Can I get black? Can you see that color, or should I change the pen?
Yes, I can see
it. Can you see it?
Okay. See it, yes, we can see it.
Yeah, if you can you use something like a pink one? It's too light.
It's too light, okay.
Yes, if you take like red or pink.
Okay, I will try them.
Stand out.
Will this be okay?
This one is perfect.
So when you check it, I'm going to draw something for you to see. Sorry, that should have been a straight line. So I'll use a box to distinguish them, and I'll tell you what they are, and I'll show you on the diagram what they stand for. Sorry. So you can draw it more perfect. If it was a book, it will have been more perfect. So this is, first of all, your condenser. This is the condenser you have here. I symbolize it with this. So there's these two things you must control in it, the pressure and the temperature, then pressure. When the compressor works, what happens? It compresses the refrigerant. And when you compress a gas, what happens? It leads to what? Higher temperature. The temperature becomes very high. And the pressure also becomes very high. If you have a note, you can draw it perfectly in your note. So when they get high, the next place they go to after the compressor is the condenser. Sorry, from the compressor, it goes to the condenser. If you see, the condenser is showing red line. Those red line means that the refrigerant is heated and hot. So this is the direction it follows. So this now becomes the condenser. The first one should be the compressor. This is supposed to be the compressor. Then this is the condenser. So when it comes to the condenser, which is this component here, you're surprised that the AC, when you on it, when you touch the one you put outside, in front of it, it's always blowing out hot air. It's because of the high temperature of the refrigerant. It's blowing out hot air. So at this point, you see the temperature will have reduced. If it was a class, I would have drawn it a more perfect, but you just manage this little one that I'm drawing. So, but after that, you'll be surprised that the temperature actually drops. So most of your technician on site, even some of us, sometimes when our clothes are wet, keys are wet, our shoes are wet, we go to put it in front of the AC outdoors. But that is not a good practice, because each time you return back the hot air into the AC, you are actually killing the compressor. That's why in buildings where you put your outdoor unit, you must have enough ventilation for it. If not, your compressor will die. And if it does break down, you are going to, because it's the only component that is more expensive, that after the AC itself is the next thing that is very, very expensive. Compressor should go between 40 to 80,000 for smaller units. For bigger units, we have a facility that their VRF AC shut down on one of the floor, and each of the compressor, while we cost for it, was costing 1.2 million, and they needed to buy 4 of those compressors, which is 4.4 million. So the client was saying, why should I spend 1.4 point something million to go and fix an AC? Why don't I just buy another one? As a facility manager, you must not get to that point. Once you see a major danger for your AC, try and solve it before it leads to a breakdown. Because clients on that particular floor started withdrawing from that building. They started renting in another place where they would get maximum comfort. So after that, don't forget the pressure is still high. After that, it goes to what they call thermostatic expansion valve. Supposed to be X. Expansion valve. The work of this thermostatic expansion valve is to reduce the pressure. So when it comes to this point, the temperature and the pressure will have reduced. And when both of them reduce, we have gotten what they call the refrigerating effect. That refrigerating effect is what is now sent into the building that brings about the cooling that most of us are enjoying. So after it has gained that refrigerating effect, it comes into this man here. Now you see that it's showing blue. Blue means cold. So it comes in here and it cools the building. And don't forget, how does it cool? It has what they call a fan. This has a fan. That fan is what causes the rotation. In your building, you see that the AC installed indoors are not always installed close too much to the ceiling. There's always a space of about 100 cm. The essence of that is that the AC actually suck up heat within your space. It suck up heat within your space and take the heat through the AC. Sorry, I'm taking me time to write this. From the space. Then when the heater it goes into the AC itself, then it comes out as cool air. It comes out as cool air. So that cool air is what gives all of us the comfort that we enjoy within a building. So all these characteristics must be fully followed because they have their own disadvantage. Like the compressor, once your power is not sufficient, your AC will not work. If your AC is a three-phase and the three-phase are not complete, it will not still work. Your compressor, then your condenser must not be covered and there must not be punctured on the copper pipe. Once there's a puncture hole on your copper pipe, the refrigerant will escape from there. And if the refrigerant escape, as an experienced person, once you see oil traces on the floor or oil traces on the copper, know that there's a leakage on the unit. So you need to take care of it yourself. Who is drawing? Win Okpa. Who is that? Somebody is drawing on the screen. Hello? Hello? Governor? Hello?
Yes, please.
Yeah, somebody is drawing on the screen. I don't know. This other line, I didn't draw this. Somebody draw that. Let them not interrupt the class.
Okay, that is not a please. Barakat,
Okay.
let's find out who is that.
So I believe, do we have an understanding up to this stage, or should you have one or two questions to ask before I proceed to the next one?
It's a normal thing that happens. It's
Okay.
from the Zoom app that we're using.
Okay, I thought it was a ghost, so we need to take care of that.
No.
Okay, so I believe we've understood it up to this point, or do you have one or two questions to answer, or should we wait till the end of the class?
Quick one before we go to the end of the class.
Do you have a question?
Yes, sir. Yes,
okay,
it's
please.
Just a clarity.
Okay.
If in a summary, we can just get the function of this compression in a compressor.
Yes.
In a summary.
Yeah. Okay, I should give you the summary of the compressor.
Yes, okay. What it does to the entire AC.
Okay. I will liken it. I just want to create an understanding. The compressor works like human heart. The heart has veins and arteries connected to it. So if you check your compressor, you see a suction line and the liquid line. So there are always two things going in. There's a provision for hot things to go out. There's a provision for cold things to come in. So its work is to compress the refrigerant. Well, in summary, the engineers, they discovered that some gas can actually cool. So in order to bring about this cooling effect, they need to find something to compress that air. And in compressing that air, they brought up what they call the compressor. So if all these stages are not followed, like from the compressor to the condenser, to the expansion valve, and to the evaporator, you cannot get the cooling required indoors. You understand? So that the single purpose of the compressor is to bring about the compression of the refrigerant gas. Only the compressor alone cannot bring about cooling. It needs other components that are lighted that must go with it. So its own work is to compress the gas. After it compresses the gas, it goes to the next stage, to the condenser. The essence of the condenser is to eject heat that the compressor has caused. So after it has caused that, it goes into the thermostatic expansion valve. That one reduces the pressure, like I pointed out here. It is when you have reduced the temperature and pressure, you get what they call the refrigerating effect. The refrigerating effect is a cool refrigerant that can be as the temperature will have dropped as low as 7 degrees centigrade. Then the heat within your building is around 28 or 30 degrees. So when the temperature is now sucked into the evaporator, there's a mixture between cold and hot. So at 7 degrees, if you have the percentage, you can actually work it out. If you have the temperature, those of us that have calculator, you can work it out. If the cold air is taking, we want to calculate the temperature. If the temperature of the AC is 7 degrees, and the hot air coming, the cold air going out of it is about, let's say 70%. So you might want to press your calculator. You are going to add the answer at the end. And the temperature in your place is 28 and is going in at 30%. This is multiply. Somebody should give us the answer at the end. So the other temperature here will be at 30% of it. You can give us the temperature at the end. What temperature will he get that is coming out of the AC? Can somebody help us to work it out? This should give us 4.9. You should give us 4.9. That is 4.9 plus, roughly, let us say this is 30. That should give us about 9. Roughly, let's say 30. That will give us 9, because this is more like 0. This is 0.07, please. 0.07. So if you multiply it, what do you get? Sorry, 0%. It's supposed to be 0.7. Sorry for that. 70.
18.3.
18.3 is your answer.
No,
So
13.3.
13.3. We have engineers in the house. 13.3. This is the temperature that will be coming out of your AC in degrees centigrade. So this other one will now work with the heated air in your space to now get it, because there's another mixture within the space too that will get it up to this point. So it is the volume of the cold air and the volume of the heat air that actually determine the outcome of what your the cool air within your space will look like. And the major thing there is your compressor that works like the heart. Like madam, like I would say, the heart itself cannot work alone. It needs other components to work well. You understand? So that is the function of the compressor. I hope madam is cleared on that.
Yes, thank you.
Okay. Can we go ahead now? Sorry
Yes.
for my bad drawing. I'm not a good artist.
Hello, I have a question.
Okay, sir.
Yeah, what happened? Okay, thank you. What happens to the compressor if there is no gas in it when the AC is no longer cooling? So what happens to it? I want to understand.
Okay,
because sometimes,
okay.
Because sometimes, you know, some engineers that comes to work in my office, I asked the guy, one of them, he told me that anytime there's no gas in the compressor and you're using it, it's likely that the compressor will get with damage, because whenever there is gas, the compressor, it helps it to cool down as it works. So I want to hear your own view.
Okay.
What do you think about it?
Okay, I will give two analogies, sir. You know, your car engine uses fuel, and if fuel does not go into your car engine, cannot, like they said, our engine is more like a mini explosive device. There's an explosion in your engine that causes the piston to move up and down, even in your generator. So by that, it works. Just imagine there's no fuel inside that generator. What happens to the engine? It knocks. It was designed to have fluid inside of it. If there's no fluid, it knocks. Even your sewage pump, if air, but it's normally supposed to take either water or wastewater out. If it suck air into it, that air is not supposed to be there. It damages the pump. Then a good example is a human. If there's no blood in our body, definitely the person will die. So putting all those things together is justify what those guys have told you. But what I will ask is it most of them will come that, oh God, that's not low for your this thing. We need to recharge. First of all, you need to find the leakage in the AC system. If you don't find the leakage, you keep topping gas every time, and it will be at your own expense. There's leakage somewhere in your AC. That's why the gas is running low and the compressor will definitely knock. And if it does knock, you need to replace the compressor. And replacing the compressor, you'll be spending so much in doing that. So they need to tackle the source of the problem before the
Refill it.
AC. Yes, before refill it. If they don't tackle it, you keep filling every time. And you know your guy say, what? I go make money from this or that. He never knows it every time we start this thing. Before you know, but serious, some of them does it because we do not have the knowledge. So when it comes with such claim next time, say, have you tackled the source of the? You'll be surprised, this man don't they know this thing. You understand? Once you tell him like that, you know that you already started having knowledge on AC. Where is the problem? And I give you a full example. You can do a physical check. If you want to discover a leakage in the air conditioning system, just go around the AC. Anywhere you see oil, that oil is actually coming out from your AC, most especially from the compressor. You know, I told you, once you start the compressor, there's an oil that melts inside that allow free flow of refrigerant. Like those of us that are engineer in the house, don't allow rubbing. If you rub iron to iron together, what happens? The surface become hot. So if gas alone move inside the copper pipe, there's every tendency it will be very hot. So in order to create that smooth operation, introduce the oil made for that refrigerant gas inside the compressor for easy movement. So when it ruptured at a particular point, those oil actually burst out of it. You know that there is a problem. Then don't forget, your capacitor also work with your compressor. Sometimes most of the problem with your system might be capacitor, but they will tell you it's compressor. And capacitor price is between 3,000, less than 10,000, depending on how big your systems are. So if you are not wise enough, the guy will collect money for compressor, but he will go to the market and buy something of about 5,000 and fix for you, and he will walk away with 50, 70, or 30,000 from you. And you will still give him a good handshake for that. So we need to be very, very cautious about it, because your aim as a facility manager is to save costs. When your client, you keep meeting your client every time that we need to change this compressor, we need to change this, they see you as an incompetent person. First of all, tackle the root cause of the problem. When you tackle the root cause, I can tell you 99.9% of the problem have been solved. Okay. So we go to we still have a lot of slides to treat. So I will have to go to the next class, please. Go to the next slide, I mean. Okay. So I've narrowly explained most of all these things. This is just a graphic representation of what I've explained before. This is the expansion valve, the condenser. You see the movement until it gets to the evaporator. From the compressor, it goes down this way and it gets here. Understand? This red sign is meaning heat is going out. This blue sign means cool air is going into the building. By this process, you give your client, your customer, even yourself, a comfortable environment to stay in. So we have, I think I will have to delete this drawing. I have cleared. How to select. So these are the basic components that your ACs need before they fully function well. Please, I've told you the enemy of compressor has been power supply. So most companies that stays on the island, if you notice that they don't have their three-phase complete, maybe in chiller system and the rest, what do? They live at the mercy of generator. And living at the mercy of generator, you keep buying what? Diesel, and diesel is very expensive. Some of our buildings sometimes run close about 50 million, 100 million in purchasing diesel in a year. Some could be less, some could be more, depending on the demands of your building. Then the enemy of this man here is when this hot air is going out, nothing should block it. Nothing should block it. When you are doing your installation too, you need to also be careful with your installation. This is the wall of your installation. And this is your plinth. Your plinth means a base for your AC. When you are installing, ensure you have a rubber pad on your AC, a rubber pad on the floor for your AC. I'm bringing out a point. This is, let's say this is our AC. you must put it on a rubber pan. The essence of the rubber pan is to ensure that the AC does not vibrate continuously and things inside are affected. Then from the wall to the AC, you should leave a minimum of 200 cm of space. I say 200 mm. That is 20 cm, 20 cm or 200 mm at the back of your AC while working. The essence is that when you install too close to the wall, there will not be enough ventilation for the AC. This 200 mm or 0.2 meters. So you can divide this and get it. So once this man is blowing hot air out, what happened? You know, I told you when I was mentioning the land and sea, nature sometimes does not allow vacuum. As the hot air is going out, all the cool air from your environment actually come to the back here and go into your AC to cool anything that is being heated inside your condenser. That's why you have those wire mesh at the back of your AC. You understand? So those things matters a lot. Do not install your AC too close to the wall. Give enough space. Then in front of your AC, give a maximum of 1 meter, minimum mean. You can have maximum, but minimum of 1 meter in front of your AC so that the hot air can actually find its way out of it. There's a building they called us for an inspection. We discovered it's one of a luxurious building in Bodilon, in Nikoi. So the building is very beautiful. People are paying premium price just to be in the building. We discovered that the ACs for the man is not working effectively. So he complained. So when we went there, we discovered that their balcony have a wall as high as this in front of the AC. No 1 meter in front. Most of the hot air is now staying inside that space. This is another wall. Stay inside the space. And the house help, the girl must be an engineer. When she discovered there is enough heat in the balcony, she now washes her clothes and the baby's clothes, Oga's clothes, madam's clothes, and put it in around this area. She becomes a natural dry cleaner. You understand? She noticed within 30 minutes, the clothes are dry. She will go in, wash another one, and put in there. Why? Because the heat from the AC has nowhere to escape. So the only solution is to open this part of the wall and allow the heat to go out of that balcony. And in doing that, because the place is high, I think it's about 7-story building, while you are doing this, you will now have to break the whole of this place and be careful of car park on the ground floor. That's why when you are doing your audit, capture all these things I have stated. It is very, very important. Once you don't capture it in your audit or your conditional assessment, you are in for a problem once the contract is signed. All the problem of the building, you and your clients sit down, discuss, and work possible solution. Then at the end, you will be insulated from any risks attached to your work in that building. So we'll go to the next one. Sorry, let me select again and select. So we'll go to the next slide, please. So there are other components that is important in the AC. We have the evaporator coil, fan. The evaporator indoor also have a fan. If this fan fails, the cooling will not stay calm. The condenser also have a fan. If the fan does not work, air cannot go out of it. It affects the compressor or the electrical component, electrical cables. When you are doing your installation, please be careful of the kind of electrical cable you have. Most buildings have been burnt down because of electrical cables. Because when they bring light on, the AC start up, and because your electrical cables are fake, there's every tendency that fire can break out. Then your electrical plug, every AC goes with a 15 hands plug, not 30 hands. People take risks using 30 hands, but it's not advisable. to use it. Then for a bigger system, we have a dryer. A dryer, the essence of dryer is to remove moss that must have gotten, that is water, that must have found its way into the system, a compressor. So this dryer actually removes those moisture. Then we have what they call the side glass. The essence of the side glass is for you to see that the gas are of quality before you proceed. The temperature sensor. Temperature sensor, the essence of temperature sensor is always in the evaporator indoors. The temperature sensor actually varies the temperature required. When you press your remote control, it's the temperature sensor that responds to the demands of what you press on your control. Then we have a thermostat. The thermostat is what you press to control while you are watching your match or you are watching one important program. Then your capacitor is an aid to your compressor. Because the capacitor, your compressor somebody is raising their hand. Okay, go ahead, Daniel. I will just go ahead. You can unmute. You can go ahead, please. Can Daniel hear us? Hello, Daniel. Hello, Daniel, can you hear us? So I have to mute you. I can't hear what you are saying. Maybe can you drop your question in the chat? Drop your question in the chat so I can respond to it there. Please, can you clarify me on AC technique? No gas in the AC. I think I've answered this question to you. How can I confirm this? So, is not. Just can you please all send your question on the platform? I will answer it from there. We still have long slides to go. Just drop your question on the chat, please. So the compressor has a high starting current and has a running current. Every AC has that because of the compressor. So I will explain the two. The starting current is the current that is required for the compressor to energize itself before it finally goes to its normal temperature. The running current is the current that ensures the compressor is working efficiently, and the running current always comes after the starting current. I give a good example. When for some of us, if you have noticed this small generator we have at home, I pass my neighbor. If you plug your pressing iron with that small generator, what does it do? Your generator because it's carrying a bigger load. But if you use even your big generator, let's say 6 kVA, it still ohms, but the system will work. What am I trying to say here? The compressor also aids electrical energy required for that compressor to pick up as starting current. The starting current can be as high as 30 amps. Then the running current can be as low as 20 or 25 amps. There's always a drop on it. So when you are sizing your system, I will advise you to always use what they call the starting current. Because when you use the running current, you will not get the size of your generator accurately. In the building I manage, the AC within the building is about 160. Just imagine the size of generator that will match that. If you're an electrical engineer and you don't match the electrical load with the size of your generator, you will run that generator down and the lifespan of that generator could be affected. So you need to take note of the running current and starting current of your AC. Then air conditioning system are of various types. As we have a lot of people online, you'll be surprised that, Oga, it is only window units I have in my facility. Another person will tell you they only have a central system, a chiller system. So we tell you they have BRF system. So here I will do analogy of what it takes. Air conditioning is divided to non-ductable products, and we have ductable products. Non-ductable products are, when you hear of ductable products are products where when the cold air has been created, they need a means to take the cool air to where it is required. So you now need to construct a duct, and that duct at the discharge point, there's what they call a diffuser. Some bigger buildings are using that means. So that is ductable. Then the non-ductable, they just do the cooling. There's no duct, like your split units. You have your outdoor unit, you have your indoor unit. They just discharge the cooling within the space. There's no form of metal connected to take the air to where it is required. You understand? So most of the ACs are designed in that manner. Even when you want to design for an office, time will come, somebody will ask you, I don't need any ductable system. I just want something you can mount on the wall that will work. You understand? Then on that non-ductable type, you will now have the split air conditioning system where you have the normal split unit we have in our various home and office. Then we have the window unit. The window unit is all compacted. All the four components I've mentioned are in one compartment. You have to open a wall, a four-corner wall, and slot it in with a burglary behind it. You understand? To prevent it, and it needs to be firm. Then under that, under the split, we now have the floor mounted and the wall mounted. When they say floor mounted, when you go to bank, you see all those ACs in the bank that they mount like that. Those ones are floor mounted, but because of their weight, they cannot be installed on the wall. Because when you are installing, you need to consider the strength of the wall. You won't install an AC and your customer is waiting for a store to collect his money. And before you know it, one AC will fall on the customer's head. If he survives it, the company will pay heavily for it. So you need to ensure, that's why they decide to put it on the floor because of its weight. Those ones that are small and they are not heavy, they decided to now put all those ones in wall. Your split unit in your home and office fall in this group. Then we have the ceiling mounted. The ceiling mounted are those things you put in your ceiling that just discharge the air and take all the return air through the center of it. Then we have the expanded type. Then we have the high the weight type, and we have the cassette type. The cassette type are the fancy type. They go along with the beauty of your ceiling board. You understand? They are very beautiful, but they are expensive. The only advantage of the cassette unit is that how they discharge their drain water, it has to be through pump because it was in a higher level. So if your pump fails, there's even tendency that your ceiling will be crying or your ceiling will be dropping water in your office. So that's why a lot of people frown at the ceiling type. But for fancy sake and aesthetic sake, some people say they don't want any AC on their wall. Everything has to go into the ceiling. So I go to this other one, the ductable type. We have what they call the package air conditioning unit. These are big, these are more like a central big unit. They are not big like the chiller system, but they are minimal. They use this for some medium-sized facility. They use them for maybe a cinema, depending on your budget and what you can afford. If your headroom is big enough to accommodate it and you have the money, you can actually go for this. But they are very, very efficient in their cooling. Then we have the central plant. The central plant can be found in bigger and mega churches, like you have in winter chapels, like you have in a high-rise building like Union Bank, you have in First Bank, you have in oil facilities, Shell, Mobile, all their headquarters are using central system. You understand? Those ones have areas where the cool air is generated through the chiller and they run that through the ASU, then ASU through the ducted unit is now distributed per floor. So all those ones need a ductable unit to pass them to where it is required. Then we also have floor standing package unit. This floor type is exactly like this, but to deliver the cool air, you now need a duct to do that. Then we have air-cooled ductable splits. There are air units that is mounted inside the ceiling, but because they are one and you need distribution to everybody in the office, you now need a duct to run in your ceiling and a discharge from the side of the duct with your diffuser to connect it. Then I will show you, maybe let me just go and I think I have some of them. It's better I show you like this so that it will, I'm painting too much figure. I'm understanding it, but I don't know if you are getting most of these things. I think pictures speak more than this description. So I'll go straight to the picture. This is the window type. This is the simplest form of air conditioning system. You don't need too much stock. You don't need too much installation to put this to use. All you need, go to your market, buy the size you require, talk to your landlord before you break his wall. So once you finish breaking the wall, just fix it in. Then get your 15-ounce plug, connect it and plug it. Then press play on it and your cooling begins to take place. And don't forget, your filter is actually on this side of the AC, while this other side is where the cool air comes out. Every AC must have a where air is coming out. Where air is coming out is called the supply air. Then where hot air is going in, which is this place where they put the filter, is called the return air. Then this other side is always installed outdoor. So the cool air from the outdoor is actually taken in here to cool the compressor. Then this is the split type. So true, because if you have this kind of unit and you open the wall, there are some funny people. Before you come back from the wall, they will have caught the burglary. Jejely drop your AC and follow that place into the building. They will check if your flat screen can actually take that space. They will, anything that can go into that space, they will take in it. So because of security and some other thing, they brought about this man, the split unit. All you need to break is a small opening on the wall, and your copper pipe is fixed in, your outdoor unit is out, and you have your indoor unit. You see the red line, this is the hot air that the system peaks in the building, in your apartment, in your space. And when it goes into this small thing, what happens to it? The hot air, the cool air now come out, which is I signify as blue. You see the method of installation. This is the finish wall to the AC. You see that there's enough space at the back and there's infinite space in front of the AC. This is a standard way of installing. Then this is the cassette type. This is the fancy type that most people will tell you I need in my building. So it's expensive, but the connection is also okay. These two copper pipe you see here are for suction and liquid line, while you have your drain at this point. Just imagine you want to drain water. The AC is just beneath here. So you need a pump that will take the water from low level and take it at a higher level. So if there's a failure of that pump, water will start pouring into your facility. Then this is a ductable type. You go to some buildings, some hotels, these are the type they use. They are very rugged. They don't get bad on time, but they cannot discharge alone. If they are big size, sometimes they use duct work to connect them. This front you see, you can connect a dot in front of it, then you do your diffuser to discharge it outside. Then this is the outdoor unit that accompanies them. Then this is a fan coil unit. This is also found in an hotel. Instead of you using a pump to pump out, you have something like a tray under the fan coil unit where all the waters are stored. Then beneath it, you now have your drain line that go. This does not require what? A pump for their installation. So all these varieties of air conditioning depend on your budget and depend on how aesthetic you want your building to look like. Then this is more like a package unit. When you see package unit, the compressor, the evaporator, the condenser, the expansion valve, all those four components are in one single unit. That's why they call them package unit. And don't forget, you see this back of it, anywhere the heat is going out, it must be connected outdoor. The cold air must always be going inside. This part of it will not be connected with a duct and now takes the hot air into the required space. And these are the components just within this kind of package units. You see it. There are areas where the filters will be installed. You can see this. You can see here is the filter. After the essence of the filter is to remove what? To remove dust. After it does, it goes well into, this is an heating element. Most of our AC in Nigeria, by virtue of our location, don't have what they call heating element. You require heating element if you want to control humidity. There are some facilities that require, where they produce tom-tom, cabaret, where they produce newspaper. Sometimes they will tell you that they need the humidity to be between 20 degrees 20%. If you now need that, you now need to incorporate what they call a heating element in between. But most of our AC in Nigeria does not have this. But in production factories, they have them. Then if this heating element have heat up, you see that the water in the air will have evaporated at this section. Will have evaporated at this section. And after that, they go into what they call cooling coil. The essence of the cooling coil is to cool the air that is passing through it. Then we now have what they call a fan. This fan is not the type you have in your building, neither the type you have as a standing unit. Rather, is a fan. It can be a centrifugal fan. It can be an axial fan. The essence of this fan is to tell the cool air that has been created into required space. So all these things you see here is a dog actually going to the space you want the cool air to be delivered. You get my point? So that is that. So these are areas you can find them. So all these systems are pointed out to you. If you check your facility, you can now, with your experience, with the knowledge you have learned today, tell your client what is best suitable for them. If you're in a very fancy building that is $1 million, you won't expect them to use a split unit. What I mean by, use a window unit, something like this. You have a luxurious apartment and you are putting window units in all the building. Come on, this is not going to be fine. If this is your choice as a facility manager, they will tell you have failed. Then this might not also be a choice in a big facility, a luxurious facility like that. These ones are always portable for offices, small businesses, school, higher institution, and the rest. This one may be a corporate organization that their profit is going down gradually. You know, when they declare their profit, they are declaring 500 million, 1 billion. They can decide to go for this system. You understand? Then the big guys in the markets, the headquarters of oil companies, the Shells, the Mobis, the Chevrons. You talk of the Cadbury, you talk of Kimberly-Clark, you talk of GE and the rest, name them. These are the brand most of them go for. These are central systems. If you see, by virtue of their cooling, their name was given. This is air-cooled chiller. When they say air-cooled, it's telling you that it is the environment air that cools the condenser. The air from the environment cools the condenser. By virtue of water cooled, you are telling them that all these things you are saying, there's a point where water goes in and water goes out. So this is how they look on ground. Baraka, okay, sorry, that was be a mistake. Are we having a break now?
Yes, sir.
Okay. You should have chatted me up. Okay, like how many break? How many minutes break?
Just 5 minutes.
5 minutes. So your time start now.
Okay.
Your time start now. Okay, no problem. 5 minutes break. No problem. So you can type your questions and we'll answer them at the end of the class. Should I go ahead? Okay. Like I said, the big boys in town, the big companies, the headquarters, most of them go for this kind of equipment. They are big in size and they are massive. So in order for you to make choice of this equipment, one, you must be careful. And you must also note that they are not produced in Nigeria. Most of the chiller systems you see are purchased abroad. And you need to be careful of the size that you picked for your building. You need to check the structural integrity of your building while you are bringing it. You must have decided where you need to place it. If not, if your building is not strong, their vibration for years could actually collapse your building. So you need to now know that every floor, you must have what they call air handling units, an AHU, that further process the hot air, then cools it and send it into the building. So I've also mentioned that their virtue of cooling the condenser has gave them their name. Like this man is cooled by air, so it's called air-cooled chiller. That is chiller. Then this is water-cooled chiller system. Then we have another type of chiller they call the absorption chiller. This absorption chiller is a very different type of chiller. It uses another technology to cool. This was one of the equipment I delivered. This one of the equipment. This was one of the equipment I actually delivered in Bath some years ago while I was in Korea. That is Mandela's. Back then, about two they bought, and they have high expenses. This should be between 90 to 100 million. Then they bought this. They needed it for their building. Um, they're actually going on automation, and the automation require a lot of engine working together at the same time. So because of that, these equipments were brought in to work. So they use their refrigerant is actually called lithium bromide. Is what they use. So they use the excess heat coming in from your generator to do the separation and bring the required cooling to all their facility and their equipment. Then this another flexible and beautiful type of AC that most people require in their building. They call it the VRF or the VRV system. By virtue of the name, the V stands for variable, the R for refrigerant, then the F for flow. It is a VRV. It now becomes variable refrigerant volume. So it's developed in, I think, in Japan, where they were looking for how to reduce the size of these bigger units, because they discovered that all these big units requires a space. And I give you an example of what happened in one of the facility. I think it is First Bank headquarters. We install about 7 of these chiller on their building to cool the building. And the beauty of that building is that they already have a roof crane on the building. And the work is supposed to be done at the weekend, because most of us that have visited Marina, you see how difficult that place is before you can navigate and get into that place. So it's not something you can do between Monday and Saturday. So the work was actually done on a Sunday. So the duty was to pick the chiller from the ground floor and take it to the roof of First Bank. And in doing that, in Nigeria, as at that time, it's only 2 persons that we know of registered and with insurance that can actually drive that roof crane. You see, when you make choices of your HVAC system, there are other things that come along. If you don't make provision for those cranes, this chiller cannot get to the roof of the building. So you must be careful while you are choosing AC for your building. Think all the possible problems that could come and try and put control measures in them. And the one that is not possible, eliminate totally. So they picked it. And in process of picking it took them close to about 1 hour to carry one on top of the building. Because when you pick, the rope that picks them about 4, they must not twist while going up, because once it twists, the chiller itself can snap. And when it falls back to the ground, you are buying full new chiller for the company. So it is a gradual process. They move and they took it. So those people looked at it and say, what can we do to reduce this problem? We need something smaller, yet still cools. So they came about this PRF. And they also incorporate energy saving mechanism inside, and also incorporate various types of units. If you check all these units I pointed before, now you need one indoor unit, one outdoor unit to work with most of them if they are DS system. You understand? But for this particular system, you see that just one outdoor unit, you have the flexibility of connecting any indoor unit that you want. You have the cassette type, you have the slim ductable type, you have the split type, they even have the high wall type. This one can be mounted on the wall. So it has flexibility. You can see how the installation is done. This is the outdoor unit. This is how the units are installed in the building. You see it. This one in the middle showing red is creating heat, while the ones on blue are actually giving the cooling required. So you can actually monitor what happens just between one unit. You have the ones that cool, you have the one that heat at the same time. And it also considers space. Yes. So we also have other type of HVAC system not listed in the presentation, but are used in various sectors. Have you ever asked what type of AC are used in a submarine? All of us know what submarine is. Submarine is a ship that have the capacity of descending low into the sea and still travel without flooding or killing its passengers. You understand? What are the kind of AC used in ships? You see all those big ships that stays 1 month, 3 months on the sea, and the environment they say is very harsh because the water that come and goes on top of the ships are very salty. So if you don't take AC that their body are well coated, there's every tendency that in the next 3 months, all the AC's body will have what? Reacted to the harsh environment and they will have rusted away. Then use what kind of AC is used in an airplane? Most of us have flight plane. Are we saying that they are going to put window unit there or a split unit or a chiller system? They have another form of cooling within an airplane. You understand? Then what are the type of AC used in the rocket? You see rocket being launched into space. And those that works in space station, what kind of cooling do we have there? They have another kind of system that was designed purposely for that. Then how do we maintain this air conditioning system? Most of the AC listed above are similar, have similar basic components: the compressor, condenser, expansion valve, and the evaporator. So your compressor is something like this. Most of us must not have seen the inside of the compressor. So this is one of the common compressor we use. You understand? You see how the indoor is. There's something that turns. There's a heating element just behind it. So I believe this sheet will be shared with you, so you can go through it at your spare time too. But this is how the compressor actually look like. Then these other ones here are the legs, the footing for the compressor. So in your AC, they must fix this stably. So while working, it vibrates. So because it is well fixed, it does not vibrate much or causes noise. Then there are different kind of compressor. We have positive display, dynamic. Under positive display, we have reciprocating, rotating. We have single acting, double acting. Then we have the diaphragm. Under the dynamic, we have the centrifugal and the axial. Those are the two ones. So depending on the kind of work you want to do, scientists now determine which one to go for out of all these compressors. Then why compressor goes bad? Low refrigerant charge. If there's not enough refrigerant is the gas that your AC actually use to cause that refrigerating effect that brings about cooling. If it is not sufficient within the compressor, it will not work efficiently. Then poor ventilation. You install your outdoor unit, there's no place for hot air to go. Definitely it will shut down. Block suction line. One of the suction line, these are copper pipe that are carrying the refrigerant. If there's a blockage in that line, there will not be flow of this refrigerant. So this can actually cause the AC not to work efficiently. Poor power supply. In Nigeria, we have power fluctuation. When you live in an area where the AC is not working, your power is not working effectively, don't expect to get the best out of your AC. Poor or bad installation. Because you want to save costs, you just call Sikira or you call Ahmed or you call a maker from where. Oh yeah, please do this thing for me. Don't worry, I will give you 2,000 naira. The guy did a very criminal installation for you. You being the facility manager, you carry the balls of it at the end of the day. Then factory problem. Some of your AC actually comes with factory problem. If you are wise enough, you can identify. And I'll give an advice here. Each time, if you have the money, I will prefer you buy the AC from a recognized, registered company because of warranty. Most companies that are sure of their product can beat their chest and tell you after even within 1 year, if our product are giving you a headache, return it back, we give you a new one. But if you buy from a roadside, you don't expect such quality service from those people. Once it's bad, they say, okay, go buy another one. Then bad capacitor. That capacitor can also affect, because I said the capacitor actually aid the starting of the compressor. So if the capacitor is bad, there's no way it will aid the compressor to start. So the compressor will not kickstart as required. So what you need to do is to change what? The capacitor. Then wrong pipe size. Every AC and size have their pipe sizes, though suction line and liquid line. If you don't use the required pipe, you underuse the AC or overuse it. Understand? Then possible solution, ensure refrigerant is within required standard, provide good ventilation, that should be ventilation, clear suction line, ensure good power supply, good installation, ensure your product have warranty, install good capacitor, then use the right pipe size. If you want to buy any product, always buy for areas where you can always get warranty, even for the parts. There are some AC that has funny name. After you buy them, you cannot get parts for them in Nigeria. I can tell you we've witnessed two different ACs that don't really have parts in Nigeria. Will you want to go and buy parts that normally cost 20,000 abroad? You know how much dollars you are going to spend bringing it in. So please, when you want to buy AC, buy the one that you know has parts, the ones you can easily get in the market. Then the condenser. So I think this one shows a better view of your condenser. This is how your condenser look like. The whole of this is called the condenser. You see the compartments for your compressors. You see it has a copper pipe. This should be a copper pipe connected to it. They are running out. Then you see your capacitor at this point here. It's always connected close to it to touch this man. Then you have some controls. A small circuit will be at this point of it. The essence of the control is to coordinate all the activities of the fan, the compressor, and the condenser. So if you check the condenser is made up of aluminum fin, then a copper pipe coil. The aluminum fin, if they are pressed too much, they can slip on themselves. It will not aid effective cooling of the condenser. So they must be totally open for air to easily pass through them. Then your copper pipe can actually rupture inside any of this part or can be ruptured along this part. Once it's ruptured, the best is for you to do a physical check. And if you can't do a physical check, there's what they call a manifold gauge that you can actually put in it. Once you put the manifold gauge, through your technician, they should be able to tell you the pressure. Something normally, if there's no leakage in your system, the pressure can be within 35 or 40 bars. But when you finally put your manifold gauge and you are experiencing 20 bar or 15 bar, just know there's a leakage in that system. Just a good example is also a balloon. Once you blow your balloon, it begins to expand. But once there's a puncture on one side of the balloon, what happens? No matter how much you pump the air in, that air will keep escaping from that area of the balloon you have punctured. You understand it? So that's how it is. Then common problem with condenser, block coil, bent copper fin, poor installation, and leaked oil. These are the problem. These are the possible solutions for it. These are very well self-explanatory. So I believe, Governor, this handout will be shared with everybody on this platform for them to go through. You cannot grasp all this in one day, but frequent reading, if there's a problem, you will not get used to most of these things on your own. Then we have what they call the expansion valve. This is the man that does reduction in the pressure. And this is how it looks like. You see how it works. There's a pin, there's a valve. There you receive the pressure coming in and allow them to go little by little, thereby reducing. This is the inlet. This is the inlet, external double line. Then this is the outlet. So within this point, the gas must have been what? Reduced. Because these components actually stop the high pushing gas and further reduce it. If the gas does not reduce, the refrigerant gas does not reduce, it will not attain that refrigerating effect we are all looking out for. So don't forget, because all these pipes are small, they could be blockage. And that blockage could actually slow the flow of refrigerant gas in and out of this particular component. And where does the blockage come from? It is when they are installing. When you bring in a technician that does not understand the principle of installation, the standard of installation is that nitrogen gas must be passed through the copper gas while you are brazing. Those that cannot afford it, they will braze ordinarily and ensure that the blowout the dust that is inside the copper. Because if we have copper dust accumulating inside it and you seal it up, definitely they will find their way into this point and start blocking things around the system. And if there's a blockage, there's no forward movement, the AC will definitely shut down. So these are the problem associated with it and the possible solution for it. Poor installation, poor phase change for the compressor, and fake TSV. There are a lot of fake things in the market. So those fake things can actually affect the efficiency of your system. Good installation, proper phase change from compressor, then use the right component. Then this is your evaporator. When you talk of a bigger system, this is what you have as what? Evaporator. Then the one you have indoors, the one that might be in your sitting room as I'm teaching now, might be something like this. This is how the evaporator look like. You understand it? So this ensure that the cool air gets to you. From the top, it suck what they call the hot air. Then underneath, it blows out this place that is open, blows out the cool air that we all enjoy. Then in front of it, there's what they call a thermostatic a temperature sensor that is always put in front of this. So this temperature sensor actually sense what is going back to the system, the AC unit itself. Then common problem with the expansion coil, block coil, low refrigerant gas can also affect. If there's a low refrigerant gas inside, sometimes the evaporator, you see ice forming on it. This same thing can also happen in your condenser coil. So you just see them forming ice, or you see some white thing while the ACs are working. Then faulty fan, gas leakage from it coil, then factory error. Sometimes some of your units come with factory error. Once they come with factory error, if they are under warranty, it can be replaced. And solution, clean or pressure wash the coil. Once they say clean, just like your car evaporator, once your radiator is blocked, what do? You pressure wash it to give you the maximum cleaning. That the essence of the radiator is to take cool air from the environment and ensure your fan is working efficiently. Ensure required refrigerant is in the unit. Don't forget, we have various types of refrigerant. We have R22, we have R410, we have R134, we have R503. There are many of them, and many are still being discovered. Please, when you buy your refrigerant, your AC is like a car. You know, we have different kind of fuel. We have the gas and we have the diesel. At no time should we buy diesel and put it inside a petrol vehicle, or buy petrol and put it inside a diesel car. You are going to create unforeseen engineering experiment, and we don't want you to end up in the process of trying that thing. In your generator, the same thing too. Your diesel generator cannot take petrol, and petrol, the generator cannot take diesel. So it's like that with AC. Each time you buy your AC, look at it carefully. The name of your refrigerant is always written on the body of your AC. Check it, you will see it there. The bar it needs to attain and work efficiently is written on the body of your AC. When it is manufactured, it's written on the AC. And they always have what they call a model number. The essence of the model number is to track it down correctly. Like we have Barakat, Suleiman, so Ejuro, we have Chris, and we have Vanana, Abi. I hope I got that name correctly.
The name is Vianana.
Vianana, I'm learning. Don't mind me. So as all of us have their names, so every AC has the refrigerant with their names. Please be careful not to mix it up. And refrigerant can be very deadly, very, very deadly. So be very careful. Then we have filter, ensure cleaner air, improve the indoor air quality. So when you're improving indoor air quality, you need filter. There's something in our body that does this filtration. Who can just say that one thing, just one thing, that does filtration like the filter?
Our nose.
Our nose, because I mentioned it earlier, very intelligent woman. Because if you check your nose, there are air particles in your nose. Even time for maintenance, our body understands maintenance period. You get it? You understand it? When there's enough dirt on the nose, what do? We use our hand to clean it unconsciously. Even for a baby or a child, they do that a lot. So for your filters, it must be cleaned regularly, because if they are not clean, there's tendency that mold, bacteria, fungi, or virus can actually be on the filters, and that can actually be spread because of your AC. So you need to wash periodically your filters, dry them, and bring them out. If you have a filter at home, you can actually, if you have the AC at home, you can actually do this operation by yourself. Just put the sleeve in your AC indoor unit open. There's a part you just press, your filter will come out naturally. You can watch it under tap water, but don't use hard brush on it because you can damage it for your home filters. Then if it is a bigger unit, you need to use what they call a pressure washing machine to wash that. Once you wash, dry it in the sun. Once it is dry, you can install them back. Then they are ready to be used. Then block filter, poor install filter, low quality filter, then using the wrong filters. So like I said, they have different kind of filters in AC. So every AC has the filter that suits it. So don't go and cross carpet the bigger filter for this particular one, or you decide to design a filter by yourself and put off the AC. It will lead to a lot of blockage within the AC. Poor install filter can also affect it. If the filter does not cover the whole stretch where it's supposed to be, some dirt can actually enter the evaporator. And if dirt enter the evaporator, it will not work well. What is supposed to boil out cold water, the cool air inside the filter is being retained because of that blockage. So you now start seeing ice forming on top of it because there's no effect exchange of all these things. So what are the possible solutions? You need to clean your filters, install them properly, then use the recommended filter for your system, then use the appropriate filter. We have disposable filters, we have a power filter, we have washable filters, and the rest, depending on your design and what you want to use. For hospitals where they have communicable diseases that are contagious, you can actually use your AC to control the movement of all these things. You get my point? So it's important you take note of all this. Then air conditioning leaking. These are issues that you might have in your system. My AC is leaking. Oh, first of all, you need to check if your AC is periodically maintained. All of us can bear weakness. Ask yourself the question, when last did I maintain the AC in my facility? Let us start from there. Ask yourself those questions. Do you have a PPM for your facility? Ask yourself that question. So when you now ask yourself series of questions, you now see that answers will surface. When you meet people that have more experience in this field, they will tell you what is required to get most of these things fixed. What can cause leakage is blocked filters, your unmaintained ACs, then your drain line not properly installed, or there's a blockage on your drain line. The essence of drain line is that any droplet from the water will actually fall into a tray and follow the pipe you have installed out of the building. If this is not done, if this is not achieved, what happens in turn is that the water will come back into your building. And if water comes back into your building, you start seeing some greenish things forming on top of your wall. And you as a facility manager, you want to make your facility a top notch. And having all this deficiency in your AC cannot achieve that result. So what do you need to do? Look for the root cause of the problem and solve it. The problem, structural defects in some cases, it may result in smell because when water accumulates too much in a building, smell will emanate from it. It may result in mold on your wall. You see some kind of thing growing on your wall. You don't know what they look like. Those mold, they ingest some poisonous gases into air, which when you take it in, you become sick. You understand? Growth of algae. You see some AC system because they've not maintained it for donkey years. You see a lot of greenish things on top of the insulating materials they use on them. It's a very bad culture. Your AC environment must be dry, neat, and properly installed for you to get a good sound AC working in your facility. Good installation, proper installation of the drain line, then install drain exit away from gutters. Some drain actually discharge where they sell, so smell can actually follow through those small holes and be discharged in your space. Then these are problems you might experience. These ones are very common. This result of this is equipment that have not been maintained for a long time. So they are blockage with dust. So the essence is that when hot air come in and inside the copper pipes, they are cool air. So if the dust has blocked all the copper coils, instead of taking it out, what happens? Those dust now becomes to form ice because they will not allow the cool air to go out. So ice will start forming on them. So the best solution here is to do what? Is to go and clean your AC, pressure wash it, ensure all the doors are out before you start using the AC. Poor cooling, it can lead to compressor failure because if the compressor is expecting cooler air, gas to come back and you see that hot air is coming back or cooler air is coming back, it can actually affect it. It can lead to compressor failure. Efficiency of AC might be affected. Your AC that is working effectively, if it is not working, is not properly maintained, the efficiency of that AC will keep dropping with time. Solution: clean bulky surface with a pressure pump. Place your AC on PPM. PPM is planned preventive maintenance. You can decide to do a quarterly maintenance. You can decide to do a 1 month maintenance. You can decide to do 6 months. But standard practice for AC is what? A quarterly maintenance. So you can start in January, then you do your 3 months and follow suit. Install AC in a very clean environment. Don't put AC in a dusty environment. It has its own implication because that your maintenance plan for 3 months will not work because the AC will keep sucking dust and that dust can cause blockage within the AC. Then remove every source of blockage. Anything that can block your AC, disturb its efficiency, please, you need to remove it. Then this is your capacity. I've explained narrowly what it does. So what you don't need to design a capacitor, but you need to know fully how the capacitors works. Then the capacitor is a commonly found electrical and electronic component in a variety of gadgets and equipment you use. You see, in a nutshell, the capacitor regulates or provides enough juice, that is power needed for certain part of the appliance to function properly. And for AC, this is the compressor. So like I said, the compressor have a high starting current. So when you plug in your compressor, because the capacitor is close to it, it aids that compressor to attain the power it requires for it to start. And if you remove a capacitor, please at no time should you use your bare hand to touch a capacitor because it has electrical charges in it. It can kill if they are bigger and it can electrocute. Electrocution might not totally kill you, but it can do damages to your tissue. You understand? So you need to be careful handling capacitor. So the easiest way to discharge a capacitor is to touch where your hand glove. I think you throw with 2 copper pipe, you use it to touch each other so that it can discharge all those charge before you start using. So be very careful about using of capacitor because the charges is inside aid the compressor to work well. So problem, poor power supply, fake capacitor, then underside capacitor. Solution, use a multimeter to check for the capacitor. Then these are required. There's a different equipment you use to test the capacitance of your capacitor. So once you test and you discover that the capacitance of your capacitor is actually 10 microfarad, when you go to the market, you are supposed to buy the capacitor of the same nature with that microfarad. That is the replacement you are going to buy. But when you measure and you see that something that is 10 microfarad is giving you 2 microfarad, that capacitor is gone. Replace it. Click sound every time when the central air system comes on. So you see, click sound. AC motor marks a humming sound, trying to run but couldn't get itself to start or run. These are possible solutions. The air conditioning unit has trouble starting but keep turning off. visual sign, the top and the bottom of the capacitor will become puff or bulge. So possible solution for this, once you see that your capacitor is bulge or puff, please, you need to replace them. Then HVAC system. Sorry, I need to see. Okay, what are the things you look out for when buying an HVAC system? You need to, when you are buying HVAC system as a facility manager, you need to check brand of your AC system. Will I want to go for LG? Will I want to go for Panasonic? Will I want to go for Samsung? Will I want, so your brand should push you. So I don't want somebody to ask me that I should recommend one. Your choice will actually determine what you want. And the choice of your client could also determine. Your client might be a brand, might love the brand Panasonic, so don't vary it. Buy the ones that is required. Sometimes the type of refrigerant used would actually determine the kind of AC you want. Warranty period on your product would also influence. Energy efficient ratio required. There are some AC that has high energy efficiency. They don't consume much energy. So if you are the lover of energy efficiency equipment, you might want to consider this while you are buying. Aesthetic of your design. If your building is the beautiful type, you don't want a window unit, you go for something that match to the quality of your building. Then your budget, you might have all these things above. Once you don't have money, you cannot get the best. Purpose of your HVAC system. Then what do you want to use it for? Is it for a church? Is it for a library? Is it for this? Your client might call you that they've just acquired a new apartment, or they've acquired a new space in a building. They want you to go and recommend the kind of AC that they will need there. So your choice or your experience can I guide you in that type that will be best suitable for those. When you are picking up a split unit, always be careful and remember that if you are on the top high-rise building, like 4-story building, 5-story building, be very careful of picking up a split unit that will be run on the wall of the building. Because one, the installation might be smooth, but what of maintenance? When you want to maintain your AC system, you now need to look for either a scaffold or a ladder. And if you need to replace the system, how do they bring the outdoor unit down from that 4-story building? Somebody could actually die. Somebody could actually fall. The AC itself can actually fall from that height and hit the ground. We came back from work one day, we saw a window unit drop from third floor and hit somebody vehicle on the ground floor. We don't know what led to it. You understand? So be very careful of installing split units on floors that are about maybe 4-story building, 5-story building, 6-story building. Please try and avoid it unless you have space that you can keep them. Space you can easily walk to and bring the AC out from inside the building, not from the outside with a ladder. So be very careful. Then maintenance of the AC. You need to consider maintenance of your AC. Is it AC easy to be maintained? Is it the one you have the knowledge to be maintained? What kind of maintenance do you want to do? Will you contract those that have installed, or will you employ somebody who have experience for the job? So you need to consider, is HVAC part available in the market? You buy an AC and there's no part in the market. If there's a failure today, how do you replace the parts? That is a problem that you need to think about. Then I think I need to drop this lower. Then what are the possible causes of HVAC failure in a facility? Poor installation. When you do your audit or conditional assessment, it will bring all these things out. Poor design. AC that's supposed to have a central system, they are now installing a window unit in the place. So you now have challenges of how air will be distributed within the space. Wrong HVAC system. You are supposed to use a VRF system, or you are supposed to use split system. You are now using a window unit. Understand? And over undercharging. Sometimes when you will over design, when you over design, it has its implication on electrical cost. When you over design, you need more bigger size of generator to run the equipment, so you pay more. When you undersize, your occupants will be complaining that they are not getting air, no cooling within this place. So these are things you need to worry about. Not taking into consideration the actual cooling load. Be very before ACs are done, the cooling load must be designed. They might call you, we want to design AC for a space. You need to let them know the kind of AC that will go in. So I will give you this. You can use 0.18 kilowatts per meter square if you are designing cooling. So it also varies depending on the area you are designing for. You can use 0.2 kilowatts per meter square. So by that, how do I design it? So you need to measure the area. I give an example. If you are called to design for a space and the space is about 10 meters square, with the formula I've given to you, like you have an idea of the cooling that you are supposed to put within that space. So if you have an area of 2 meters square, and I give you to use 0.2 kilometers square per meter square, and 0.2 kilowatts per meter square, and the meter square within that place is 10 meters square, what will be the required cooling for that space? Let's multiply 0.2 times what? 10. So that 10 will give us what? 2 meter square. So by definition, the 2 meter square could actually be 2 meter by 5 meter, or it can either be 2.5 by 4. So you now determine the kind of AC you want to design for. So that 2 kilowatt, you cannot decide to divide it into 2. If you know that the place is very big, you cannot decide when you go to the market, you are going to buy 1 kilowatts, that is 1 kilowatts times 2 to install in this place. The essence is that you want everybody within that space to benefit from the cooling. There you get. So distribution also might be a factor while you are selecting. Then conditional assessment audit of a facility. We've talked about this in all my videos. So preliminary audit or pre-audit or walkthrough audit, short audits, 1 or 2 days to discover the actual building, its actual HVAC system, its actual use, and its actual occupancy. So when you are doing your audit, you need this audit could also be used for every other component like a restroom, the building space, the kind of chair that is there. If they say the chairs, you can do your audit and say the chairs are bigger, and maybe in a space where you have 20 persons, they told you they now want to put 30 persons in that space. You know that the present chair arrangement cannot work. You now need to now do some modification on the chairs. Hello, I hope all are still online.
Yes, we are
Yes,
with you.
Okay. I need. Okay. Can I go on? Can I go on?
Yes, sir.
Okay. So you now need to ask, should I change all the chair sizes to accommodate 30, or should I say one person should chair 1 seat? You know that is not possible as a facility manager. So the first thing you need to think for, you identify the problem on your conditional assessment. You can put them on your Excel sheet. Maybe under furniture, you put chair. The challenges on site on that place is that the chairs are big. So the possible solution, we need a size, maybe a chair that will fit into 2 meters square. That will take 1 person. You can change the size smaller, you can make it bigger, depending on what the client wants. So you need to work with the client and their standard within a facility that you must use to divide your space. You understand? So that you can fit in the 30 or further reduce what is required. So the same thing is done in AC. When you are taking your walkthrough, check the required temperature of AC in that building. Take your record. You can go with a measuring device, temperature measuring device. Check the temperature. Ask people, have there been any complaint before? If you need to ask, then check the reaction concerning the AC. You can do one-on-one discussion with the AC, whether they've had issues with the AC before. All those goes into your report that you are going to give your client, and you guys sit down the round table and do all those things. Then you can do action taking place during the preliminary audit, checking the envelope, use the structures, visual inspect the plan, check for the presence of all that is operation and maintenance activities and contract. Then the other thing you can use to check also is the contract you guys have signed. On the contract, what is required by the client? If the client said, please, we've given you contract to ensure that the AC within that place should be within 20 degrees centigrade, are you meeting up to that standard? In your data center, they say they need 20 kilowatts of cooling. But when you are doing your condition assessment, you discover that you are having 10 cooling. You note it down. Why are we having less than what the contract has stipulated? When last is the equipment maintained? Why is this equipment making noise? Do we have somebody that regularly check this equipment every day? So these are questions that should reflect on your day. So you can go through the book, get all the things you require for it. Step required for carrying out the audit: gather building design data, document for information. So when they finish the building, the architect must have done a handing over to you, to the building owners, or to the landlord. So what you need to do is to gather the building, check if there been any utterance in what the building was installed with and what it is now, and you now relate it to where you want it to be. If it is sufficient, be very sincere enough to say it is okay. If it is not sufficient, give your comments why it is not sufficient, then possible solution to reduce the effect or impact on the objectives of the organization. Visit site, it is important. When you are doing audits, don't sit in your home and start calling somebody that is inexperienced. Please go there, go count the number of AC when they get there. Just take the temperature. The person didn't even know how to measure temperature. You just go there, they've not on it. It's a manual, you wrote 88. You know, when they buy manual, there's this sticker they put on top of it that shows 88. The guy just look at, this temperature is 88. He just wrote it down. He doesn't know how to use it. So if you take such person's data, it could impact on you, because you as a facility person, you should be able to detect when something is wrong, even before it comes back to you. Definition of profitable solution and action. Because when you finally get the solution, how much will it cost to rectify? What are the action required? Is it action from your part, action from the landlord, or action from the space user? Do you understand? Then you start planning for what they call reporting. You understand? Then under the action, you could also do what they call retrofitting, upgrade, or relocation. Those are language that will come under this solution or action. So you understand? Then this is what a checklist look like. Then if you have all your guys on site, you need to prepare what they call a checklist. A checklist is what they must check every day to ensure that the ACs are working fine. You having a car, when you park, when you start your car in the morning and you are driving out, you hear one funny sound. The next thing you do is to call your mechanic. Okay, mechanic, what is happening to my vehicle? I'm hearing one sound from this left side of my vehicle. Please come. You don't wait till when the thing disappoints you on the road before you call the mechanic. That is what you need to do. So in order to reduce those risks, you must create a checklist for your technician on site or for the company maintaining your equipment. So you see, check and ensure proper refrigerant charge and procedure. Inspect all voltage and absorption components. Check thermostat operation for accuracy. Inspect breakers and fuels for proper functioning. We've gone into a building where AC shut down. People didn't know why the AC shut down. There was lights everywhere, but ACs are not working. You know what the problem is? The twin switched off, the breaker trip off in the DB. Nobody knew. After many hours, somebody just say, let me just check the DB. They just say that there's a breaker in the DB that gone off. They just switched the power and the AC started working. So sometimes when there's a flick in light, standard design for electrical companies checkmates all those excesses before it gets to equipment. So if you have such, first of all, once your AC is not working, the first thing you must check is power source. Is power supply to the AC? If yes, why is the AC not working? You now need to do physical check, whether the indoor unit is working, the outdoor unit is working, and if they are not working, why? If you can check well, everything about the indoor is working. Let me go to the outdoor unit, whether it's the outdoor. You now discover the outdoor is not working, or it's working, you see some kind of sound, it's coming out from me. Probably the capacitor has gone, or the compressor has gone. So through the checklist, your guy, your technician on site can easily say, madam, oga, this AC, yesterday night when I go out, so I check out, the AC no dey work. Before your client discover, you have already called your client that we are having problem in this particular space. Probably it's a meeting room. You might not want to allocate that for a meeting room because there's a problem with the AC. You can allocate another one pending when this issue is resolved. Then plan preventive maintenance. What does this take? Plan preventive maintenance allow you to substantially reduce reactive maintenance. You take care of the work, substantially reduce reactive maintenance, and retain your building and assets at a desired level of quality. Time-based preventive maintenance is based on a fixed execution frequency of activities that generate a calendar schedule. So you need to put all these definitions into consideration. I remember when I was working in a facility, a generator was working very well, but it got to a particular, I think 250 hours. The man said, we are going to change the oil today. But I said, this generator is still working. I was still little then. This generator is still working. I said, oh boy, we don't wait here till when it breaks down. Once it has attained 250, we must change the oil. That is the standard they set for themselves. I can assure you that generator has not broken down one day. So don't say until the sound start coming from your generator before you fix it. Please don't do that. Ensure that your planned maintenance is followed periodically. Your filter must be watched, the capacitors must be checked, your cabling must be checked, your plug must be checked, the refrigerant pipe, physical defect in the copper pipe must be checked, your insulation must be within quality, and you give your client the best option of a top-notch service that you'll be commended for in the future. A maintenance strategy. So preventive maintenance, corrective maintenance. So it depends on the kind of facility manager that you are. You need to choose whether you are the preventive maintenance facility manager or the corrective type. You see the preventive maintenance, periodically your equipment are maintained. Predictive, your equipment are taken care of, then plan, you see all the time. Periodic is a time-based service, part replacement or overhaul, including periodic inspection and lifetime replacement. Then under predictive, surveillance, monitoring, testing, in-service inspection. Then under plan, you have what they call condition-based servicing, part replacement, overhaul, refurbishment, and modification. These are what is required. And the other side, if you belong to the group of this man, what did they say? Run to failure, unplanned failure. Temporary repairs, overhaul, refurbishing, replacement, or modification, inspection, ah, let's see here. Inspection and failure diagnostics. So I'll prefer, if you have not been doing your preventive maintenance well, I'll prefer you join this group. You definitely record, create what? Efficiency or delivery service. Then the other thing you might want to do is to open up an Excel sheet and do a plan preventive maintenance. How do I do it? This thing hard for me. Oh. Look at this man now. This is a 31 days maintenance schedule. What do they do? First of all, what are the equipment you want to maintain? Is it a generator? Is it AC? Is it a car? Is it a lift? Just name them. Are they pump within your site? Maintenance tasks, what are you supposed to do? You list them out. Then prepared by who prepared it? Then time spent, prepare it, then you put a schedule. Then you can also design it to suit your purpose. What I do on my site is that I list out the equipment to be done. I list the frequency for it to be done. I list the name of the company or my personnel that is in charge that needs to take care of it. I list their name or company. I put their phone number. Then I put the frequency which this thing will be done. Like here now, I can decide to put January. I use weeks sometimes. So all of these 4 months, you can target on your Excel sheet to be January. Then week 1, week 2, week 3. Which of the week in January, if it is a monthly service, maybe it is every second week of January. You want to, every month you want to do. So in January, you just use your color code in Excel to put it either green. Then you go to February, look for second week, you do it until December. Then the ones that is quarterly, maybe in January, after January, you count another 3 months, you put it there, you do all those ones there. Then what other thing you could also do as a facility manager? You could also make use of your calendar in your system. You can do a reminder on your phone. You list all these things on your phone, put them on alarm, on reminder, that 1 week to that time, there will be a reminder for that equipment maintenance, so that you start calling the vendor, start booking time they need to come in, or you start alerting. Then if you know you have so much money, there are software that can actually do this. They call them e-CAFM software. They regulate your maintenance. When your equipment is due for maintenance, the software sent you an email or a text message on your phone telling you, sir, your generator is due for service 1 week from today. So it enables you to start making productive plans to ensure that the equipment does not run down. Then how do heat get into space? You might wonder, how does heat get into space? You see here, heat gets into space through the number of activities that the space actually do. The human introduce heat into space. The electrical equipment introduce heat into space. Your light introduce heat. The building orientation introduce heat. So all this heat needs to be taken care of. If you check what is happening here, you see all the arrangements. This is a dehumidifier they install here, air dot, outdoor in, that is outdoor air intake. This is a fresh air coming into the building. You see the air dots, and this is a dehumidifier. Dehumidifier is to remove quantity of water in air. If you go to building on the island, most of them use dehumidifier in their building. The essence of dehumidifier is to create a dry environment. Because if you stay close to Ikoyi, you will be surprised that your humidity can be as high as 90. So this can create mold and bring bad organism, bad virus, bacteria, fungal effect, all the water in air through that equipment, making your environment very dry. So those microorganisms cannot actually come. You see heating coil, when you want to vary the condition of the heating, introduce a heating coil. A cooling coil is also, then dehumidifier is something that add water into air. Maybe you're in an environment where the air is so dry, like in the north, where everywhere is dry. You want the place to be within average. So you can introduce what they call humidifier. So those one will pump water into air and ensure that your space is within required space. Then don't forget, every air that comes into space must find their way back into the unit for recooling. You see, this is a return air grill. All the return air are following through this part, going back. You see the arrow. Then all these ones are supply air diffuser. All these ones are taking the cool air into space. And as they are taking it, there's a sensor that is connected to your AC system that tells it what to do and when to do it. Then heat gets into space through human, electrical equipment in operation, lighting, your light bulbs, solar heat gain through the sun, location of your building. If your building is built and it's full of glass, and when the sun rises, you are the one the sun greets first, you'll be surprised that there will be more heat within your space. Then what are the possible solutions? For human, you cannot stop human activities within the space. So you must make adequate cooling for that human. Electrical equipment must be well placed. You can also not do anything about your light bulb. You can decide the solution. Instead of buying all these incandescent light bulb, you buy what they call energy savers. Along the way, people discover that in light, what they need is not the heat. What they need is light. They started reducing the heat and bringing what they call energy saver. If some of us have done poultry before, you remember that poultry, because they needed heating equipment, they always use those yellow bulb that we have, because they give light and they also heat up the space. Do you understand? So that heat is what we don't need. So you might want to use energy saving. Then location of your building, you don't expect the cooling in Lagos and that of Meduguri to be the same. So where your building is located also matters a lot. Activities carried out within the space also introduce it. Then AC installation tip. If you want to install AC, these are the tips that you must follow. Strength of your wall to hold the AC, proper spacing between the wall and the AC. I've mentioned that. Appropriate installation height from the ground, correct tint angle of indoor units, correct location of your outdoor unit, proper placement of outdoor unit, right distance between indoor and outdoor unit. When you install split unit, the standard design required is between 12 and 15 meters from indoor to outdoor. Anything beyond that, your AC will not work efficiently. Use proper electrical cable. Use 15 hands plug and above. Do proper vacuuming of your AC while installing. Ensure there is no leakage when you are commissioning your AC. Use proper refrigerants for your AC units. Then the last one here. Use thermostat. Ensure thermostat are installed. If you don't have thermostat, that means you have to get up most of the time to put on or put off your AC. So for standard company and luxurious home, they will require this for their system. Then you see proper installation of AC. See how everything is perfectly aligned and how they are connected. This is a standard installation. You see the roof. You see how they place them above the floors, and the rubber pad is placed under them for installation. You see the copper pipes, the way they follow are well insulated. Then on the roof of a building, maybe in a shopping mall, most of the AC units actually go on top of the roof because they want enough parking space for their customer coming. So this kind of AC may be encouraged, might not be encouraged. So in order to solve this, you might want to design a central system, just one unit cooling the whole factory. But if you want individual control, and if it is a resident, this is the result of what you get. And since it is on top of the roof, it's not disturbing anybody, unless somebody flying over your place with an helicopter that will say, see the structure of this building and the way the ACs are installed. I think that will not be a problem. It's just one out of almost 120 million Nigerians that will worry about that. Then this is a chiller installation in Bath. I actually delivered this to Bath also. This is one of the chiller they install in their factory. This is when we're actually dropping it down, be ready for installation. In every chiller system, there must be a plinth or what a more like a mini foundation for it. Then under the AC, there must be a vibration pad that must install. So you don't allow the vibration of the chiller to eat the plinth because they will be cracked, and the AC, the chiller system, could also be affected. Then this is a VRF installation. Because of space requirement and because of the number of flats it needs to cool, these are installed in these parameters, and you see how the copper pipes are well installed, and each one descend into the building and connect each of the floor to all their outdoor units for required cooling. And this is your indoor unit. That is your indoor to your outdoor unit. That is how they work. You have a section where you have, this is supposed to be, okay, the two-way valves. This you can, if you want to lose, you can actually lose it from on top of here with a spanner or adjustable spanner on this part. Then you can use your Allen keys to open through this place. This Allen key can actually lock. What does it do? It lock. It's sometimes you allow your refrigerant to enter through this maze, and you can also discharge through this maze. This man you see here is what they call the manifold gauge. This is the digital time. They use it to check the pressure of your AC. They can also use it to charge your AC. They can also use it to pump down your AC. And this is a thermostat. This is how it look like. You see the connection that is done here. And there must be a communication between this man and this man. So when you are doing your connection, all the electrical cable of the outdoor unit must be connected to the indoor units. So when you on it from inside, because they are together, the electrical power is now sent into the outdoor unit to make them. So ventilation, the other thing you might need to worry about is ventilation. You might ask, is ventilation important? So I will tell you why. Ventilation is the process by which clean air, normally outdoor air, is intentionally provided to a space and stale air is removed. This may be accomplished by either natural or mechanical means, or ventilation and its intentional introduction of outdoor air into a space Ventilation is mainly used to control indoor air quality by diluting and displaying indoor pollutants. It can also be used to control indoor temperature, humidity, and air motion to benefit the thermal comfort, satisfaction with other aspects of indoor. You know, when you are in your car and you see that the car is getting hot or stuffy, what do? We wind down to get fresh air. It's not every time you require cooling. Sometimes you need fresh air for you to work well. If there's no ventilation in a building, there's every possibility that the person can suffocate and the person can die. Efficiency will drop, productivity will drop. Then type of ventilation, we have mechanical ventilation, natural ventilation, then mixed mode ventilation. These are things required within a building. And areas where you need ventilation too is your kitchen. If you have kitchen within your place, when people cook in the building, you need to take it out. Even within your space where you work, people sometimes come with smelling body, people armpit smells, the kind of food they eat smells in the building. So you need to take all those things out of the building. Then slowly introduce a fresh air. When you perceive some kind of offensive odor within the place, what do? In a space, you open up the window for fresh air to come in. But for AC, they have a means by which a mechanical component can actually bring in the fresh air without opening your windows. So most of those things, these are things that sometimes you can use to bring in those air, you understand? Then OA is outdoor air, then RA is return air, then this one is supposed to be supply air. This is a ventilating system on how the AC fresh air come into space. Ventilation is needed in kitchen to remove smoke or smell, needed in toilet to remove smell, needed to supply fresh air into space. Different type of air in space. We have the supply air, the return air, the exhaust air, and the outdoor air. Supply air is the cool air you receive. The return air is the heat that the AC is taking away. Exhaust air is what is going out through smells and other things we need to play. Outdoor air is what is bringing the fresh air into the space. So this is how a ventilator or heat recovery look like. See, when this thing is installed, you see, this is a fresh air going in. This once you see this part, you know that this is installed in a space and this one are going out. This is outside air coming in, needs to be go through this component, then it bring in fresh air. Then this return air is actually going out, go through this man and bring out all the smell and the smoke within the building and take them out. So softly, it cleanses the air within the space. Then air handling unit is a component that aid or work together with the chiller system to bring about cooling required within a building. Then AHU components. These are the components you can find in AHU. You see then there are different components. The first one is a filter. You have the heating element, the cooling coil, the electric motor, then the fan. The fan is always connected to a door that takes the cool air into space. So these are the components you find in most of those stuff. So I think I've taken much of your time, and this is my handshake here, though it's a corona period. So I'm not supposed to put this anyway. So thank you very much and I appreciate it. So I can welcome questions now. Hello. Okay, I'm seeing some questions here.
Hello, thank you.
Yes, I'm done. Oh, this question time. It's 2 minutes to finishing to 7. Okay. Oh yeah, go ahead. Oshinaike Francis, please.
Yes, sir. Good evening, sir.
Good evening.
Thank you for the lectures. Okay. Please, can you remind me again what is the name of the app you said we can use for maintenance planning? The one that can send a reminder for each maintenance.
ECAFM, electronic. Yes, ECAFM, computer-aided facility management.
Yes, but I think this one is a particular, that is ECAFM.
ECAFM, or you can call it it's ECAFM or CAFM. If you Google it online, you see a lot of only that you pay for most of them. You understand? You pay for more, they are not free. Somebody sat down and draw the application, they sell it. So what I do, now that you have Teams meeting does reminder. You can program yourself on Teams. you can send it to yourself. You can use even some software within your system to do a reminder to yourself. If you don't want to spend much money, you can use your phone too. Your phone has a calendar and can also do reminder. So you can take your time to program all the equipment that needs maintenance in your phone. So when it's time for reminder, like now, if I want to do birthday for my kids, my wife, and the rest, it tells me a reminder. I program it that tell me 2 days before the day, so I can plan myself before that day. So that reminder, use the electronic to control how you do your thing, and this will increase your own productivity, make you more efficient in delivery, and definitely the end result is always promotion.
Okay. Secondly, sir, when you were given a how to calculate the possible capacity of AC in a space. Yes. So if I have a 20 square meter space, you said it should be what? Okay. Sorry, I mixed that part.
There are various formula you can use. Okay. If I want to design now, there's a software they call HAP. They call it Hour Analysis Program. So what the HAP does is that it has various days in a year. In a year, we have 365 days. Yes. So what they do, they've done their calculation and see the hottest day in a year. It is that hottest day they use in calculating. So what I'm giving to you, they call it rule of thumb. That rule of thumb, I have not considered everything in total. Don't forget, the rule of thumb will not consider the number of people in that space. The rule of thumb will not consider the location of the building. The rule of thumb will not consider if the building is built with glasses or built with wall or wood or maybe a container at this iron type. It's not considered, it's just a rule of thumb. So most of the time, it might not work. So it's not based on experience.
Okay.
I've been in the field, so I can easily know when to use a particular factor to calculate. Do you understand? You being new, it will be a little bit difficult for you to apply, but it is worthwhile for you to give it a try. So like I said, it is 0.18. You can use 0.28 kilowatts per meter square.
0.28 or 0.18.
You can use for it, the values vary for 0. If I'm designing for Lagos, I might decide to use between 0.18 to 0.13. Then if I'm designing for Maiduguri, I will use between 0.3 to 0.5 meter square, because I know that area is of high temperature. So I need a bigger value to get the required cooling within that space. But nevertheless, because it's my field, I have the software to design for cooling, the hour analysis program. I design it myself, take into consideration the number of people, the kind of activities they are doing, what are the heat generating for the electrical equipment within the space. I need to know the orientation of the building to the sun. I need to know whether it is in northeast, southwest. Then what is the building located? Is it made of iron? Is it made? There are a lot of factors that are strength up to 30 that you must consider before you decide the heating load. In a smaller system, in a smaller space, you might not want to consider all. But if you want to do a precise and a standard work, you need to consider them so that they will know you are professional in your field.
Okay. Yes. Thank you, sir.
No problem. Any other questions? I expect the women in the house to ask questions. The men too should ask questions.
Hello, sir.
Yes.
I think any other question will be sent to the group chat and be forwarded to you, sir.
Okay, we are kindly send your question. Okay, I've sent that.
Yeah.
In a water cooled chiller, is it that the cooling is generated by the in and outflow water, or is it that no, okay, this question is for Chimeze, sorry. Okay, this question, what the water cooler does, water cooled chiller does is that the water is actually cooling the condenser. If you listen carefully to what I said initially, let me go to the first page. To the first page. I want to show you one of the drawing. Okay. Let me just show you this briefly. You see this? When I do that drawing that time, I said when hot air is going out, the cool air from the environment must enter the condenser to cool it. So we can tag this as what? Cool split units. So, but for water, instead of air to cool it, you are not passing water through it to cool it. That's why it gets the name. So the water aid cooling, but it is not the one that is doing the cooling. It aids it. What does the cooling is the air that is within the space and the component that actually takes the hot air and brings out the cool air. So I hope I've answered that question, Chimeze. Then the other one. Sir, why is it that on a VRV and VRF system, you require about 80 to 90% of the indoor to be put on to get a better cooling? Example, is it if a sitting room alone is put on, the cooling is not efficient unless other? I don't know. Are you a designer? If I'm asking, are you a designer?
We have it running in our facility at the moment.
No, it depends. No, you have it. The essence of creating a VRV is to save energy. So you don't, unless the cooling within that space is much, that most of the ACs have to work on time. That is the problem I have with open space. When you have open space and you're having one person come to work or 3 persons come to work, the whole of the AC must be on. But for split unit, if you are on within your office, it's only that split unit in your office you on. You understand? For VRV, the principle behind it is that even if you on it to 100%, because the AC has a sensor, it's sending in a temperature of 17. If 17 is coming back, he is not happy. Some compressor will shut down. If he's sending 17 and 20 is coming back, some compressor will come up. Are you getting it? He can sense difference in temperature and work to reduce the energy being wasted. Because if you on your chiller continually for 24 hours, if you have your electrical, you can calculate it. If you have your power, you do your power. Power is times voltage, then multiply by hour. Then you look for the Nigerian kilowatts per hour they charge. You can calculate the energy your AC alone is using in a day. Then when you on it for 12 hours, how much are you saving? If you on it for 12 hours, that means when you put it in thermostat, that it should be working for, it should off for 10 minutes and come back on after 10 minutes. If you set it at that set point, it can work like that. You'll be surprised when you add that 10 minutes for 24 hours.